SUERF, the European Money and Finance Forum, bringing together policymakers, finance, and academia.
Welcome to this SUERF Banca d'Italia, ECB, Suomen Pankki and Oesterreichische Nationalbank workshop on challenges and recent advances in modeling and forecasting inflation. There are various hypotheses on the reasons for central banks and economists' failure to forecast inflation adequately over the past 2 years. First, an extraordinary series of multiple shocks, including geopolitical, demand and supply shocks, which could, or at least were not anticipated correctly or not incorporated in the forecasts. Second, a wrong diagnosis of the shocks once they occurred, delaying appropriate policy responses. Third, a misdiagnosis of the pass-through of energy and global value chain shocks to the wider economy, including the behavior of profit margins and wages. Fourth, over-reliance on the credibility which central banks enjoyed during the Great Moderation. Fifth, a poor understanding of the complex, far less than perfect, formation of agents, that is notably households and firms, inflation perceptions and expectations. And sixth, inflation targets and monetary policy forward guidance geared towards inflation overshooting as a consequence of monetary policy strategy reviews narrowly focused on inflation undershooting. At least 4 of these 6 hypotheses have links with and implications for central banks' inflation models and forecasting tools. This workshop groups the issues at stake into 4 sub-themes. Session 1 will deal with inflation forecasting learning from errors, so it's a sort of stock-taking error analysis. Session 2 will deal with inflation perceptions and expectations, which have turned out to be more complex than even anticipated before. Session 3 will deal with inflation forecasting, new avenues for improvement. The aim is to have new models, methods, data usages here. And Session 4 will deal with inflation dynamics and large supply shocks, so the focus is on supplies that cause push shocks there. Before we start, let me thank the co-organizers and members of the scientific committee for the great and smooth cooperation in putting together this program. Without further ado, I hand over to Juha Kilponen for session 1.
Thank you, Ernest, for this very good introduction, and welcome also from my behalf to this webinar on modeling and forecasting inflation. We have in the first session 2 presentations. First one is from Benoit Mojon from BIS, and the second one by Pirkka Jalasjoki from the Bank of Finland. So Benoit, without further ado, the floor is yours.
Thank you very much, Juha, and thanks to the organizers for inviting the BIS to speak on this very critical challenge for central banks. And I'm presenting you today several of the works which have been conducted and are being conducted in the BIS to try to understand the dynamics of inflation, the inflation process, and possibly how to forecast inflation. Before I jump into the substance, I'd like to clarify that the views expressed are mine and not necessarily those of the BIS. We report here 4 numbers for each country. The green number corresponds to the latest inflation number, so that's October. And then you have the red dot is a forecast for 2022. The yellow dot is a forecast for 2023. And the black bar or black range corresponds to either the inflation target when it's numerical value, which is the inflation target, or as in the case of Canada, Australia, or Colombia, you have a range And you see that this range tends to be slightly higher and wider for emerging markets. That's the case in India, in Brazil, and also in Indonesia. So what we see here across the board is that with the exception of China and Japan, the red dot is way above the black bar. It's close to 8% for several countries in advanced economies. It's even above 10% in Russia and Chile. It is almost everywhere above the inflation target. What is remarkable, though, is that in spite of inflation being way above the target in 2022, the expectations, the forecast for 2023 is that by end of 2023, a big part of the way back towards the inflation target will be completed. If you look on the right-hand side at South Africa, so that's ZA, or India, or there you see that the yellow, or Brazil, you see that the yellow dot is within the range target of the central bank. That's also the case for Thailand. If you go to advanced economies on the left, okay, there you see that in countries like Germany, or if you take the euro area as a whole, inflation forecast will still be, inflation is forecasted to be still way above the inflation target at the level of 4% or above. In the US, it's slightly below 4%. This view that inflation is going to come down very fast, okay? Because it goes from 8% in December this year to 4% in December next year for the typical advanced economy. It's not so comforting actually, because as we have seen in 2021, and people who forecast inflation are very familiar with this left-hand graph. We see here for the euro area in red and for the US in blue that you have at the beginning of 2021, we were expecting inflation in both areas to be close to 2%, slightly above 2%, and in blue for the US, and slightly below 2% for the euro area in red. And the plan line that you see here is showing you, how much inflation surprised us, and in spite of these very large surprises, that we've not seen in 1.5 generation for 40 years, so 1.5 generation, this type the magnitude of this inflation surprise yet do not lead forecasters to consider that possibly inflation will stay higher instead of returning towards the value of 2% at the end of 2023. And you see here these forecasts are still fairly optimistic in terms of the path back towards inflation, in spite of errors on the downside for every forecast which were made since early 2021. So now, if we look at the evolution of forecast for 2023, you see that this is giving you the path of inflation forecast for 2023 as they were updated throughout 2022. That's on the left-hand side, with a trajectory again for the US and the euro area on the right, with different vintages. So on the right, we have the March, the June, the September 22 vintages of inflation forecast. And so what's striking is that even though the inflation forecast for 2023 have been revised up consistently, forecast after forecast in 2022, there is still the view that in spite of this very high level for 2023, so the forecast for next year, it will come down eventually in 2024, which we see on the right-hand side for the US and for the euro area. the question that we asked ourselves and we covered in the annual economic report of the BIS, which was published at the end of June 2022, but also in this bulletin by my colleagues Fiorella De Fiore, Marco Lombardi, and Daniel Rees, is do we see a changing pattern in inflation? And to some extent, yes, but not so much. Okay, so that's the conclusion of this slide. So here we report the cross-sector spillovers. That's the left-hand side, and we compare the dots for different periods. And the pink bars, they correspond to the average spillovers for a sample of of advanced economies on the left of the left panel, and a sample of the emerging markets economies on the right panel. We are focusing here on the square, which is on the left of this slide. So you see that the red dots, which corresponds to the latest estimates, which are from January to June 2022, we see that there is more contagion across sectors in the economy. And to some extent, the second panel is showing this as well. We could not gather data with a long historical depth for a large number of economies, but we could do it for Mexico, Japan, Korea, the US, and Canada. And there, the blue bar corresponds to the extent of cross-sector spillover of inflation for what we call high inflation regimes, which were up to the mid-80s for advanced economies, and for low inflation regime, which are the 90s and the 2000s for advanced economies. And you see that this cross-sector spillover represented by the blue bar, it's a share of the variance which is transmitted to other sectors. You see that it's been much higher in Mexico, which has experienced very high inflation, but also for the high inflation regime that we had in the US, in Canada, in Korea, in Japan during the 70s. And the two green bars corresponds to the low inflation regime that we stopped in 2019, so the plain green bar, and the dashed green bar is when we expand the sample to include also the last 2 years. And there you see that there's a small increase with the exception of Japan, but a very small increase actually in the spillovers across sectors. If we move to the third panel, the increase of spillovers from prices to wages, so that's how much wages respond to past inflation. You see as well with the same decomposition that wages respond much more to past inflation in high inflation regime, the blue regime, and then in the low inflation regime, the green regime. And if we expand the low inflation regime to the last 2 years, there is a sign of an increase in the response of wages to inflation, but not necessarily the symmetric increase, in the sense that we did not see prices respond more to higher wages when we add the last two years in the sample. So some evidence of regime changes, but not overwhelming, far from that yet. Here, what we have in this paper is a taxonomy of the type of indicators that you may want to look at. I don't have the time to go through every cell, but let me list the type of indicators that we are considering are useful to look at. First of all, inflation itself. So that's very important, obviously, for obvious reasons. We want also to look at sectoral price sub-indices, so the sub-indices of the CPI or the PPI, for instance. Then it's also useful, in our view, to look at expectations, either market-based or survey-based. And finally, you may rely on models to decompose inflation into its various sources and what is influencing inflation. And then, for each of these indicators, we assess its timeliness, how informative it is about the drivers of inflation, whether it can help you forecast where inflation is likely to go, and finally, because if you contrast countries with very high inflation with countries with very low inflation, we think the dynamics of inflation is not the same. And I showed some elements to back this argument in the previous when commenting the previous slide. We also assess the robustness with respect to regime shift. And let me focus on this last criteria, because at the current juncture, this is what may be the most relevant for us, because us central bankers, we care very much about getting the best understanding of monetary policy, impact on inflation, and for this we need a good model of inflation, even if the parameters of this model has changed. So in terms of inflation itself, it is the objective, so there's no question that you keep looking at it. In terms of the granular measures, it's in part tautological, but if you see that inflation is spilling over more across sectors, we take this as an indicator of a change in regime, and that's what we documented using historical data. Now, in terms of expectations, from market expectations and survey-based expectations, there we have mixed evaluation. You may be able to see from financial markets that and option prices that there's an increased demand for protection against episodes of high inflation. And this you would be able to decompose option prices, which are indexed on inflation expectations, to make this measurement. But this is not universally accepted, in part because some of those option prices, and it seems to be more the case in the US than in other countries, there's very, very little trading on them. So, the validity of the signal that these option prices are giving on the probability of very high inflation or very low inflation, if not deflation, is questionable. Moving to the line 3B, expectation survey based. So there is one indicator which could be revealing a shift. And this is when you see that you observe the full distribution of these inflation expectations, and you observe basically by modality. And there's a group of households or corporates, a larger group that expect that inflation is going to be very high. And to the extent that these guys are better informed about what's going on in the economy, it could be the canary in the coal mine with respect to future inflation. On models, it's an open discussion. If you have a good enough structural model, it should be able to capture change in regimes, but models parameters are typically constant, so it's not clear that they can help you see a change in regime. If we want to think out of the box and the traditional model, so we go back to basics. One is that inflation is always and everywhere a monetary phenomenon. Here, actually, if we divide countries below or above 4% average inflation, we see that there's a much tighter connection to monetary growth in the countries with inflation above 4%. And actually, the excess money growth, which is money minus nominal GDP in logs, over the period before before the post-COVID, the first period after the first lockdowns, there we see that there is a positive correlation between excess money growth and the forecast error of forecasters for this period, going all the way to Q3 2022. So there may be information when inflation is high. There may be information useful for forecasters. Here we exploit the cross-country cross-section variance to show this. Another out-of-the-box question is, is inflation global or local? Because we see inflation rising across the board in many countries. Here we report actually the extent to which the variance of inflation in 23 countries can be seen as a spillover from US inflation. And this is the sum of this index across 23 countries. And what we see is that in the period of low inflation, given that each point here corresponds to a 15 years window regression, so say from the early 90s to 2019, you have this very flat line. While near the end, you see an increase of this line to levels that corresponds to the period of the 70s and the early 80s. However, what's also remarkable is that this spillover from US inflation to the rest of the world, the period where it's been the highest actually was during the disinflation of the 80s and 90s that you see covered here with this big hump at the middle of the graph. So there as well, in international spillovers, there may be hints at ways to forecast inflation better. Let me conclude. So obviously, forecasting inflation is very challenging. We see breaks in the dynamics of inflation post-COVID. This may reflect unusual shocks, including global ones, which impacted the vast majority of countries. And there is some evidence of change in the slope parameters. For instance, something that that governors from many central banks are telling us in Basel is that the pass-through from imported price and exchange rates and commodity prices has been much faster this time around than had been for the 20 years before COVID. So we have mixed evidence from various indicators and models. So far, that's the good news. Limited evidence of anchoring of inflation expectations and forecast, what I was showing at the beginning of my presentation. And if we look, out of a traditional forecasting model, there may be interesting information on inflation coming from the patterns of money growth, but also evidence of international inflation spillovers seem to be resuming. Thank you very much for your attention, and I'm ready to take questions, if any.
Thank you very much, Benoit. After the COVID, we also had a period with a very strong fiscal accommodation. Could it be related also to that? Some people argue that the inflation can have important fiscal roots as well.
Yes, so actually, we didn't do the cross-section yet, but it's clearly very atypical fiscal stimulus in a number of countries following COVID. The line we have in the BIS is that it was extremely difficult ex ante to calibrate both the monetary and the fiscal support for the economy because we were confronted to lockdowns, something that we had never encountered before. And we didn't want to see some perverse dynamics with chain reactions of corporations being bankrupt, for instance, and dynamics like the Great Depression. This being said, the rebound was much faster than we had expected. The capacity to turn the economy on after turning it off, we may have been overly optimistic, and so supply did not react to this bounce back of demand that we had experienced. And one observation is that if you look at core inflation, not headline inflation, but core inflation in the US is indeed much higher than in several other countries. And it is also the case that the fiscal stimulus of the Biden administration has been much, much bigger than in other parts of the world. So it's not a full cross-section, but your intuition, I think, is very legit. I concur that fiscal policy stance can explain some of the variance of demand.
The question from Hervé Lebihan. So I will read it for you here, and please a quick answer to that. So don't you think fast pass-through is just a reflection of large shocks in the state-dependent pricing logic? Then when level of, say, gas or oil stabilize, firms return to a more normal behavior.
So actually, let me quote very interesting evidence that co-author of Hervé has shown to us recently in a keynote speech in Zurich that was 3 or 4 weeks ago. And actually, we see a change in behavior. That was Fernando Alvarez who showed that for recent evidence for the UK and the US, you see an increase in the frequency of price increases in microdata, which is similar to the one that was observed in Mexico, where they have a long time span to observe the frequency of price increases and price decreases. And just for those who are not aware with this research agenda that Hervé Lebihan at Banque de France and Fernando Alvarez are working on with microdata, typically the frequency of price increases is flat, and so is the frequency of price decreases. And what we've seen is in instances of high inflation, so in the past in Mexico, but also more recently in the US and in the UK, where Fernando Alvarez has recent up-to-date data, there's a large increase in the frequency of price increases. So it's intuitive, but at the same time, given that inflation is higher, it's somewhat intuitive, but at the same time, it's also worrying because, it's a leap of faith now to assume that firms can increase prices and that when inflation comes down, they will just stop. Can we be so sure?
So thank you very much, Benoit, for this excellent start of the webinar. I suggest that we continue now with the presentation by Pirkka Jalasjoki.
Thank you. The paper is undergoing a substantial revision right now, but I'll present to you the paper as it is right now. Of course, the usual disclaimers apply here at the bottom of the slide. Inflation has been surging lately, and we know that a main driver behind that has been energy product prices. And hence, energy prices have also driven major under prediction of inflation rates by all forecasters and also the ECB included. But what our paper is looking at, or what one might ask, is that okay, how about during times before the current crisis? How have the energy prices affected the ECB forecast for inflation? And partially one thing that we're also looking at in the paper is the part of the role of the oil price assumptions. How do they cause bias into the in the ECB forecast? We all know that inflation forecasts play a central role. They are at the core of central bank communication. And we know that central banks can affect private sector's expectations. And we also can expect the inflation forecasts to remain important in expectations management and also to serve as an additional policy tool. And especially in the environment where we are, for instance, discussing make-up strategies which create expectations that inflation will over or undershoot its target. And also, of course, in anchoring inflation expectations when inflation surges. And this is, of course, very topical right now. And as Benoit just showed us many of these points already, but I'll just repeat some of them here. So we know that the accuracy of central bank forecasts deteriorated during the financial crisis and also during the COVID-19 pandemic. And after the financial crisis, many central banks consistently overestimated inflation. And then after the pandemic, during the reopening of economies, central banks have now consistently underestimated inflation. And what these repeated large and systematic projection errors may do is that they may increase the risk of de-anchoring inflation expectations, and they may deteriorate the credibility of the central banks. So now we get to the actual ECB forecast, and here in this graph, all of the inflation forecasts made by the ECB are shown, and these are all the forecasts made between 1999 and 2021. And here it is shown with the blue line, the actual realized observed harmonized index of consumer prices inflation rate. So that's the blue line, and the black lines are the different vintages made by the ECB, the forecast vintages for inflation. And of course it's a bit of a mess here, but you can see that you can see both the signs of under prediction and over prediction depending on the phase that the euro area is going through there. I'll show you another graph from which shows the same forecast from a little bit different point of view. So here we have the forecasting horizon at the x-axis. So we have different forecasting horizons, 2 quarters ahead, 3 quarters ahead, and so on, up until 11 quarters ahead. And then we have divided all the inflation forecasts into 2 groups. We have blue group and the red group. And the red group, for instance, when the ECB is making its forecast, a single forecast, if the latest observations for inflation rate in the euro area, if the latest data that the ECB observes, if it's below a certain threshold, then that particular forecast is thrown into the red category, the red group, and vice versa for the blue group. If a forecast is being made at times when observed inflation is above a threshold, then that forecast goes into the blue group. And the threshold used here is 1.8%, and I'll explain in a minute why this figure here. But as you can see, already after 4 quarters ahead forecasts, you can see the convergence of the both groups converging really quickly to ranges that seem to be quite close, but below 2%, which happened to be also the price stability or the target inflation rate target for the ECB of the ECB until July last year. So one may ask that, okay, how this behavior that we can see here with these both groups, how does it affect the forecasts? Because of this, do we see some bias depending on inflation that the ECB is observing at the time when it's making its forecast? And this is what we're looking at here. So what we're asking is that, are the ECB inflation forecasts unbiased? And we find that yes, they are unbiased on average. So no bias there. But if we look at state dependency and we defined the state as the level of inflation when the ECB is making its forecast, and for this we apply a new test by Randal et al., a recent paper. As I said, we define the state as the level of inflation at the time of forecasting, and we find that the ECB overpredicts inflation when observed inflation is below the threshold, and we find similarly that the ECB underpredicts inflation when the inflation is above the threshold. And so we find evidence of state dependency there. And thirdly, this is the thing that I discussed right in the beginning. The ECB is in making its forecasts, it's using exogenous assumptions. these external assumptions that the ECB gets, for instance, from the financial markets. And we're looking at some of these assumptions, and we want to see that whether controlling for errors in these assumptions, whether this removes the state dependency from the ECB forecasts. And what we find is that these assumptions explain partially the state dependency, but they do not fully account for it, or for the state dependent bias. Excuse me. So in equation 1, we have defined our dependent variable. We have epsilon, which is the forecast error. And in equation 2, we have the linear model, which is testing for the overall on average bias in the sample. And there we have epsilon, the forecast error, is being explained by a constant mu and the error term u. And the null hypothesis is that there is no bias, that the constant is equal to 0. And the question that this test is answering is that does the ECB systematically under or over predict inflation in this whole sample? Then we have in equation 3, we have the state dependent model, and there we have the epsilon is being explained by the constant again, the error term u, and now we have an extra term that consists of theta, which is a coefficient, and then we have the function g, which is a function of the state variable s and the threshold gamma. And in the equation 4, you can see that if the state variable s exceeds the threshold, then the function g gets the value 1 and 0 otherwise. And this state-dependent model answers us, if you look at the last bullet there, the answer that it provides us with is that does the ECB systematically under or over predict inflation when inflation is above or below a certain value at the time of making the forecast. I'll skip this slide, but I'll just mention that the last bullet is showing the way we calculate our state variable, and there the pi q is the last full quarter that is observed, that is the year-on-year, the quarterly year-on-year inflation rate of the last quarter, and pi m1 is the inflation rate of the first month of the quarter in which or during which the forecast is being made. So the state variable is simply an average from these two.
Pirkka, you have 4 minutes.
Okay, thanks. Okay, finally some results. We have up in the upper left corner, we have the on average bias, so not dividing the sample in any subgroups. We have all the observations here lumped together. And the positive bars here mean that on average, the ECB is slightly under predicting the inflation, but we don't have much statistical significance here, so we can conclude that on average there is no bias. But then we turn to the state-dependent model. On the upper right corner, we have the threshold estimated for different forecast horizons, and we find that they're really tightly, we're very close to 1.8% for each forecast horizon. And then on the left bottom corner, we have the green bars, which show that when inflation is below the threshold, the estimated threshold of 1.8, then the ECB is over predicting inflation, and the red bars on the bottom right show that the opposite effect. When inflation is above the threshold, then the ECB is under predicting inflation. So we have evidence of state dependency there. So again, we find no bias in the linear model. That is on average in the whole sample, and that's because the negative and positive errors cancel out, so there's no bias on average. But we have the state-dependent bias that I just mentioned. And if you look at the fourth bullet, you can see that the evidence of bias is strongest at the medium horizon, which means forecast horizons 3, 4, and 5 quarters ahead. And the average bias is a bit less than 0.4 percentage points. So maybe not this year, but in, let's say, so-called normal times, this would be a significant, like a major discrepancy. And we also find that the threshold value, the last bullet, we find that the gamma is in line with previous literature. I'll skip this. I'll just mention that it's not necessarily totally irrational for the central bank to have biased forecasts, but I won't go to the possible motives there. I'll jump right to the role of the external assumptions. So we're looking at the first 3 sub-bullets here. We're looking at 3-month Euribor, Euro USD exchange rate, and the Brent crude oil prices. So here's the energy part that I was talking about in the beginning. And I'll just mention that in equation 5, we're controlling for errors in these assumptions and see whether controlling for the errors of the assumptions removes the state dependency that we observed earlier. And if we look at the right-hand side, the third column of this graph, we have the oil prices there, and the green bars show us the situation where the inflation forecast is made when inflation is below the target or below the threshold, and you can see the overprediction there, and then on the bottom right, you can see the red bars, and you can see that controlling for the oil prices, controlling for the errors in oil price assumptions, we still have also the other effect. So when being above the threshold, when inflation is above the threshold, then ECB inflation forecasts underpredict the actual inflation. So if you look at the 2 first sub bullets here, the magnitude is the state dependent bias. The magnitude is unaffected, and the significance is unaltered when we control for the errors in the external assumptions, including the oil price, the future prices of oil. We've also done robustness analysis. We've tried different specifications. We've tried to alter the state variable, the threshold. We've had different subsamples, but we still find the results quite robust. We've also looked at 5 quarters ahead forecast for the ECB, for the survey of professional forecasters, and the consensus forecast. Since the 4 quarters ahead forecast is the only reasonably comparable forecast horizon, we find state-dependent bias, evidence of state-dependent bias only in the case of the ECB, although not that strong for specifically 4 quarters ahead forecast. Conclusions: we document 3 novel findings. We find systematic bias towards the target, which implies over-prediction when inflation is low, and vice versa, under-prediction when inflation is high. We find larger bias when inflation is above the target, and the bias is larger at medium horizons. The results are robust. And the question is, how can we explain the state-dependent bias? Well, we can say that the external assumptions are not enough. So the oil, for instance, by itself is not enough to explain the state dependency or state-dependent bias. And further investigation, we have some plans to study dynamics of pure forecasting models to see if we see similar behavior there, and maybe study also expert judgment and strategic communication motives. But thank you.
Thank you, Pirkka and Benoit. Now, if we continue to the next presentations and next session, which will be chaired by Matthieu Daracq-Pariès from European Central Bank.
On our session now, we start to dive into the expectation, let's say, agent expectations about inflations and econometrician forecast about inflations or trend cycle decomposition about inflations. We will have 3 presentations, one by Marta Bańbura from the ECB, another by Randal, Verbrugge, and Saeed Zaman from the Fed Cleveland, and then Danilo, Cascaldi-Garcia from the board. And now we'll give the floor to Marta. Marta, please.
Yes, thank you, Matthieu, for giving me a chance to present my work. So in the next 10 minutes or so, I will talk about my recent work on incorporating inflation expectations into forecasting models. I guess this audience does not need much of a motivation, so inflation expectations are important for central banks, are closely monitored, and in particular, they feature very prominently in the latest strategy review of the ECB. However, if one takes a look at what kind of models are used in practice when forecasting inflation, expectations are very often not included. And if they are included, they are only included in certain ways, and it's not clear why one way is used and not the other. So the general question arises, do inflation expectations contain information that is otherwise not captured in other inflation indicators or drivers, or cannot be easily summarized in a macro model? So given this introduction, I will talk briefly on the following points. So in particular, I will start by discussing what are the ways that we could include observed inflation expectation in model-based forecasts. Then I will turn whether it actually helps to include such information in a model, and in particular, given the multitude of various available measures of expectations, which are more useful, which are less useful. Finally, how robust are these results across models and areas, and do these conclusions survive essentially like the latest 2.5 years? So I will be mainly drawing on the work that I've done with Danilo Leon and Jan Oliver Menz, and with Frederica Brenna, Joan Paredes, and Francesco Ravazzolo. To pre-warn you on the scope of the analysis, so this will be mainly on time series as opposed to structural models on the euro area, and including some largest member states. And the evaluation period will be mainly from early 2000s to end of 2019, with some results based on more recent data during the pandemic and thereafter. So starting with how can we incorporate expectations in a model. So we essentially propose the 4 highly stylized groups. First, expectations can serve as boundary values, where essentially you would constrain your model in a way that long-term inflation forecast converges to the expectation value. And some of the models that I listed here allow for some bias in this relationship. So most of the models in this respect would consider long-term inflation expectations. However, there are also works that would use short-term expectations to inform the nowcast of the model. And the influential handbook chapter by Faust and Wright tells you that basically if you use these 2 boundary values, it's not so much important what you do in between. As a second way, you could simply include expectations as explanatory variables, so essentially as a regressor as any other. Third, to tilt on constrain the model forecast. So this would be shortly exposed. You would produce, model-based forecast, and then you will modify in a way using some moments from your expectations. And finally, you would inform model parameters, notably by taking some prior values based on expectations. And most of the papers find improvement when doing this with few exceptions. And now turning to the results of what we do. So there are like the 2 papers. In the first one, we essentially consider Bayesian VARs and ADL models, and we look at 3 different ways of using expectations, namely as boundary values, as explanatory variables, and to inform the priors. And in the second paper, the second paper is based mainly on Bayesian VARs, and we essentially consider 2 strategies which complement the results of the first paper. First, SPF, is treated as simply as a forecast as any other, and is included into a pool with all the model-based forecasts. And in the second strategy, we tilt model-based forecasts to the SPF mean or variance. And in particular, we are interested on the sequencing of this problem. So, should you first tilt individual model forecasts and then combine it, or should you do the other way around? So in order to assess those different strategies, we perform real-time out-of-sample forecast evaluation, where we are very careful on matching the information that is available to survey respondents with those that we pass to the models. We look at point and density forecasts. We're interested mainly in medium-term horizons, so 1 and 2 years ahead. And we also look at the different measures of expectations. So a lot of focus is on the SPF, but we also evaluate professional forecasts of consensus economics, expectations of firms and households from European Commission, and also expectations based on financial data, precisely on inflation-linked swap rates. And we mainly look at the euro area, but we also cross-check the results based on country data. So the first chart focuses on the euro area and on the information from the SPF. And the horizontal axis in both charts basically denotes all the various model types, which I will not give details. If you're interested, you can look at the papers. And for each of these model type, we construct a version with and without expectations included. And we do real-time forecast with both versions, and then we compare the root mean square forecast errors of both versions. And the bar below 1, so below the red dashed line, means that the version with expectation is more precise. And you can see that for most of the model versions, this is the case. So this is a relatively robust result across models, across forecast horizons, and these results are for headline HACP, but the same holds for HACP excluding energy and food as well. The second observation is that that the forecasts are are modest, I would say. So there is no magic. So there is systematic improvements, but the improvements are typically limited. Now, turning to a different measure of expectation. So this chart is a rotated version of the previous one, if you will. So now you have different model versions on the vertical axis. And the dots that are to the left-hand side of the of the vertical one at one means that expectations help, and the dots that are on the right-hand side mean that expectation actually worsen the performance. And the different colors refer to different measures of expectations, where red is consensus economics, black are the expectations of firms, green are expectations of consumers, and yellow dots are based on financial market data. Where I should say that for the latter, we can only use essentially one model type, because for the euro area, this data has very short history. So as you can see, if you look for the dots on the left, these are mainly from consensus economics, meaning that other types of expectations do not really lead to improvements in forecast accuracy. And finally, looking across countries, so we don't have SPF expectations for the countries, but we have the expectations from consensus economics, which we use in this exercise. And different colors correspond to different countries. Two different charts refer to two different forecast horizons. And again, the dots that are on the left from one mean that expectations help improve forecast accuracy, which is the case for most of the countries. Now, turning to the second paper, where we look into this optimal pooling and tilting strategies based on BVARs and SPF. So here in this table, the first column provides some accuracy measures for the optimal pool of the BVARs. Then the second column, the second and all the remaining columns provide results relative to the first column. So essentially, the values below 1 mean that the strategy in a given column is better compared to the optimal pool of models only. And it turns out that for what regards forecasting inflation, the optimal strategy is tilting ex ante, so individual models, to the mean of the SPF. Another observation is that SPF actually seems to be overconfident. So this rows denoted as pits show you that actually their good calibration is rejected for anything that involves SPF or tilting to the SPF variance. So essentially the SPF distributions are too narrow. And finally, as I also promised you some results for COVID, I mean, the sample including COVID and thereafter is relatively short. So in order like to summarize the results, I plot here a difference of cumulative sum of squared forecast errors of versions with and without expectations. So meaning if you have the line that is below 0 and trending downwards, it means that that the model with inflation expectations is better than the one without, and it essentially involves gradually forecast error starting in 2020 Q4 up to 2022 Q2. So for most of the models, again, expectations help. Perhaps one thing that is a bit interesting is that there are some models which are very off. And this is in particular the blue dashed line. And this means that some models struggle with COVID observations. So all these models were in a way built or constructed on pre-COVID data. And what you see here is that some of them need to be adjusted to be able to deal with this new norm. So to summarize, the results that I just discussed show that incorporating information from mean expectations from professional forecasts helps, and this result holds across models, strategies, and countries, although the gains are modest. When it comes to expectations of firms and households, or those based on financial data, we actually do not see systematic improvements. In terms of point forecast, the SPF is actually very difficult to beat. So there is essentially no model that is better than the SPF, systematically over time. However, the SPF tends to be overconfident. If you think, about the sequencing when to include SPF, it appears that it's good to include it early on. So it's better to correct the model ex ante and only to combine the corrected models. Regarding the most recent period, SPF seems useful also for including model forecasts after 2019, and actually some tentative results show that it also helps to correct the variance. So this is somewhat different to the situation before. And the reason for this is that many models struggle with an accurate estimation of forecast uncertainty. And in this respect, SPF can also help. So also the second moment of the SPF. So the broad conclusion is that the expectations from professional forecasters should be included in the model, as they seem to include some information that is difficult to replicate. And to finish, let me just point out some direction on which we are working currently. So one regards the role of surveys during the pandemic and the high inflation period. So, it might be that surveys might appear very important or very useful now because your models, have hard time dealing with this atypical observations. But once you correct, so once you incorporate the recent advances in modeling, this advantage of surveys might disappear. And this is something to be seen. Another point is how to derive future paths for survey expectations. So some of the models that I presented before rely on future paths of expectations, if you will. And normally one would use some autoregressive model to pad in this future path. However, given the recent extreme observations, it is not obvious that this is actually optimal way to do. And second, do surveys still provide timely information? So there is this older paper by Elmar Mertens showing that actually in the 70s and 80s, and the expectations contained by surveys were somewhere behind the curve. So they were like, signaling changes in trends in inflation in a somewhat delayed manner. And it will be interesting to know what's going on now. Then in terms of roles of surveys or expectations in general in predicting pace of inflation, so this is something that's actually a large group at the ECB and the central banks, or ECB, is looking at. So and the results should be published, I guess, sometime next year. And there's always also some additional work on new ways to incorporate off-model information, including those from expectations or from surveys. In particular, colleagues of mine are working on parametric tilting, so in particular tilting to a skewed t-distribution. And there is also interesting works by Clark et al. On tilting to SPF histograms. Thank you.
Thanks a lot, Marta. Please, Randal, the floor is yours.
All right, thank you. Thanks for the organizers for inviting us to present at this conference. And our paper we're presenting is simpler than the previous one, but hopefully enlightening nonetheless. So, as everyone knows, as the economic recovery began after the COVID pandemic, inflation rebounded quite sharply. So by June, for instance, of 2021, CPI inflation had increased to 5.4%. Over the previous 12 months. And the key question at the time was, is this transitory? And many experts said yes. This question is still relevant today. And in fact, Saeed and I have some other research suggesting that without a recession, inflation is going to be well above target at the end of 2025. And by the way, this paper sees a big role for non-energy price shocks and is estimated on pre-COVID data. And it's a boundary value model, as Marta said. But in any case, getting back to this paper, the question is, where is inflation going? And an obvious place to search for clues is inflation expectations, as Marta was talking about. Perhaps these expectations summarize lots of dispersed information. That's important. And also people's expectations about future inflation can help shape future inflation. So we wanted to examine, what inflation expectations seem to matter. And the reason we want to do that is because there's these different expectations measures, and they don't always agree. And there's no consensus, in fact, on which are the most important. So we're just asking which one performs best, and hopefully we won't be telling you it depends. Anyway, here's a graph of some of the different inflation expectation measures for the US. We're showing in red from households. Professionals are in blue. Financial markets are in gray. And then there's a recent survey from the Atlanta Fed on business inflation expectations in yellow. And you can see they're very different at times. So the question is, do any of these help? And it's, partly the same kind of question was asked in the previous presentation. So here's the four that we look at: inflation expectations of households in the Michigan survey. For professionals, we're looking at blue chip because we're doing a monthly analysis, very similar to SPF. Inflation expectations of firms. The firms are asked, what's the inflation of your cost going to be over the next year? And that's what we're using. And then financial markets, as explained by the Cleveland Fed model, which takes a bunch of information from financial markets and translates that into inflation expectations. So what we do is we examine the predictive relationship of each of these four measures to CPI, core CPI, as well as median CPI and trimmed mean CPI. And in the paper, we actually look at cross correlations, in-sample predictive relationships, and also out-of-sample forecasting. And we look at two sample periods. One is sort of the longer one from starting in 86 to 2021. The second one is from 2011 to 2021. And as I said, we're using monthly data and just looking at 12-month inflation rates. So today, we're just going to show you some of the results we have from in-sample predictability, as well as out of sample. And then as a bonus, we're going to look at the COVID or post-COVID period, being optimistic. And the preview of the results is, as we saw in the previous presentation, professional and business expectations are best, and consumer expectations are worst. But I want to put an except at the end of that. All right, so what do we do for the in-sample predictive relationships? You know, we're just running here a simple regression where on the left-hand side we have inflation from today to 12 months from today, and then we're regressing that on one leg of that. So inflation from 12 months ago to today, as well as we include the indicator value of the particular expectations measure we're using, that's the ST. And then we're interested in this coefficient beta. Is this close to 1? If it's a very good predictor, then that should be the only thing that matters. So beta should be close to 1, and R squared should improve a lot. And then we just look at this for various, we use the 4 different, you know, in sequence, the 4 different expectations measures. So here's our results just for CPI and core CPI from that particular exercise. So if you look at column, the chart on the left, that's for headline CPI. The beta coefficient is all we're plotting here, but I'm indicating, you know, by a red box, those models or those expectations measures which involve the notable improvements in R squared, and then the ones that are highlighted are the ones that are statistically better than the other ones. So you can see in the first headline chart, you know, over the entire period, the financial markets and blue chip do pretty well, much better than household expectations. Over the shorter period, you know, where we can estimate the business inflation expectations, those and the blue chip are the ones that are best, but blue chip is the best of those both. And for core CPI, results are somewhat similar. Again, blue chip is the best performer in this from this particular exercise. But we can also look at things out of sample where we just take the expectations measures by itself, look at it over time, how well was it doing in forecasting, and then we just compute the root mean squared error from this. And we can see from this exercise, you know, the top, this page, we're looking at CPI and core CPI. The top panel is looking at the longer sample period, and you can see the root mean squared error from the professionals is much lower than the other options for the full sample. For the shorter sample, we have kind of a tie between financial markets, blue chip, and business inflation expectations. And for core CPI, you know, it's blue chip and business inflation expectations. So these are very similar, I think, to what Marta was finding for Europe. And then we do the same thing for median and trend CPI. These, you know, are better measures of trend inflation and arguably could be considered better measures of inflation overall. And we find very similar results here that professionals, you know, give you the best forecast. Yeah, I won't say anything else about that. But it turns out that expectations of consumers are not always worse. So I will let Saeed pick it up from here. Saeed, can you speak now?
Randy, you can continue. I will go to the next slide. Yeah.
Okay, so if you can see on this slide, we're just plotting, you know, in a figure, root mean squared errors from the various, you know, from the purple is the consumer inflation expectations, which, as you recall, did much worse over the 1986 to 2021. The second one is financial markets. The third one is professionals, and the fourth one is business inflation expectations. And you can see for both CPI and core CPI, household expectations did much better over this period. Go ahead, Saeed.
Okay, great. Thanks, Randy. And continuing further. So you know, in the recent past, Randy showed that household expectations have consistently outperformed other expectation measures. I would say this is consistent with the theory of rational inattention. And just to provide a quote here, more recently, Chair Powell of the Fed said at the Jackson Hole that when inflation is persistently high, households and businesses must pay close attention and incorporate inflation into their economic decisions. So when inflation is low and stable, they are fair to focus on their attention elsewhere. And this is like, you know, consistent with this, the fact that higher household attention to inflation is associated with higher ability of household expectations to predict future inflation. And more recently, there are these two papers by Bretz and Mitchell and Oesterreichische have provided empirical evidence that show that consumers are currently, over the past 1 year, are quite attentive. Next slide, please, Rani. So to shed further insights on the ability of the household expectations to do better when inflation is high, I would like to take this opportunity to highlight soon to be completed work with my Cleveland Fed colleague, James Mitchell, titled The Predictive Content of Inflation Expectation Measures. So in this new work, we examine the predictive ability of inflation expectation measures across the full distribution of inflation. So that is, we model the distribution of future inflation as a function of inflation expectation measures and the current inflation. And what we do is we employ quantile regression methods similar to the ones used in recent work, including by Francesca Loria and her co-authors. And so far, what my colleague Wendy has presented was about the predictability of the conditional mean of the future inflation via OLS linear regressions that involve regressing future inflation on observed predictors such as inflation expectation measures, which are denoted by symbol S in the equation shown on this slide, and current inflation. So this approach is surely useful and simple, but it ignores any possible nonlinear dynamics in the estimated predictive relationships and so provides an incomplete picture. Whereas this other approach, quantile regression, the quantiles, that is the percentiles of the distribution of future inflation, are expressed as functions of observed predictors. And so possible nonlinear dynamics kick in if predictors, observed predictors, affect differently the different regions of the inflation distribution. And so the main question in this new study is that we use this quantile regression methods to assess whether the predictive content of inflation expectation measures varies across the inflation distribution. Next slide, please. Thank you. So to give you a preview of the select number of findings in this new work, we find that there is a strong evidence of nonlinear relationship between household expectations and future inflation, in that the ability of the households to predict future inflation relative to the professionals and the market increases with inflation. Again, now this is consistent with the research on rational inattention. Households find it beneficial to invest more in the construction of their forecast when inflation is high. Secondly, we show that the joint predictive ability of all three inflation expectation measures, household, markets, and professional, is greater than the marginal predictive content of individual measures when it comes to forecasting 1 year ahead, headline inflation or core inflation. So our work emphasizes the importance of tracking all the expectation measures, but importantly, differentially weighting different agents' expectations of inflation when assessing inflationary pressures in a probabilistic sense. In other words, all expectations are useful, but some are more useful than others. Next slide, please. So in this slide, I provide visual evidence of this nonlinear dynamics in the estimated relationship between household expectations and future inflation uncovered by our quantile regression approach. So the chart here shown plots in solid red the estimated betas, that are the slopes of the univariate quantile regression of future inflation on household expectations in the left panel and on the expectations of the professionals in the right panel. The x-axis here represents the quantiles, that is the regions of the inflation distribution. And in each panel, the OLS slope of the linear regression is plotted in dashed blue, along with the 95% confidence bands generated under the null hypothesis that the true relationship between inflation and the expectation measure is linear. So as you can see in the case of household expectations, that is on, looking at the left panel, the linearity assumption is clearly rejected, as the estimated betas are significantly different at the 10% level from the OLS beta. That is the red line falls outside the shaded gray area for most of the time. And the betas differ significantly across the quantiles. The betas increase dramatically as the quantiles increases, suggesting that household expectations are more informative of tail inflation outcomes than they are when inflation falls toward the middle of its density. In the case of professionals, with estimated betas staying largely within the shaded area, the assumption of linearity is not rejected. Next slide, please. So not surprisingly, this nonlinear estimated relationship between the household expectation and inflation translates into a nonlinear predictive accuracy of the household expectations relative to the professional. So shown in this figure is a plot comparing the density accuracy score of expectations of professionals to that of the households across the quantiles of the inflation. Ratios less than 1 indicate that professionals are more accurate than household, and ratios greater than 1 suggest household is more accurate. As can be seen that for quantiles 80% and above and for 4% and less, the expectation of households do a better job in predicting 1 year ahead future inflation than professionals. But for all other quantiles, professionals are more accurate. Moving on to the last slide, please. Okay, to sum up, we find that on average, professional and firms have provided more accurate predictions of headline inflation 1 year out compared to households. However, in the recent period of elevated inflation, households have consistently outperformed others. In-progress work that examines the predictive content of expectation measures across the inflation distribution confirms the superior predictive ability of the household expectations when inflation is very high. And in assessing the inflationary pressures in a probabilistic sense, the optimal approach, we think, is to track and combine various agents' expectations, but weight them differently. And we show that quantile regression method is a suitable approach to achieving this combination. Thank you so much.
Thanks a lot. And I would propose that we right away give the floor to Danilo.
Thank you very much for including our paper. The views on this note are solid. The authors does not represent the Board of Governors or any other person related to the Federal Reserve System. We've seen the evolution of consumer prices have moved swiftly from concerns about deflation during the height of the pandemic to fears about excessive inflation. And it's hard to find any parallel in the history of both in the US or in the global economy of this reversal of risks to inflation outlook. Haven't seen this rapid reversal as we see it now. So what we're proposing here is kind of maybe an update of a measure of trend inflation. It's a way of trying to gather information from the economic agents in a single measure that we can evaluate how is inflation perceived by the economic agents. And the idea of trend inflation is that it tries to reflect the public confidence in the central bank's commitment to price stability. I'll start with the economic intuition, then I'll show a little bit just on the statistical procedure, but the economic intuition of the model that we're using here is that the underlying inflation is a trend that is informed by inflation expectation, in this case by surveys. So the idea is that this underlying inflation is a trend that can be affected by the beliefs about the conduct of monetary policy. The trend inflation is a stable in quotas because it depends on the period, but it's a stable measure of inflation expectations in which would inform us what are the expectations over a period far enough in the future. The idea is that this trend it's highly dominated by the central bank's commitment rather than just cyclical factors that would affect inflation. And specifically in our case, we're taking signal from past inflation, from trimmed mean measures of inflation, the ones of our colleagues from the Cleveland Fed, and also from short and long-term survey expectations or forecasts. It is a nice setup because we can actually evaluate the level of the anchoring of both the level of inflation and also the uncertainty around this level being formed by just long-term inflation expectations. From a statistical perspective, what we do in practice is that we estimate a monthly model for the United States. We borrow the model from Elmar Mertens, so I hope we can answer a few questions that Marta already posed during her presentation. And specifically for the trend, we updated through March 2022. So the statistical definition of trend inflation, this tau t here, is the infinite horizon forecast of inflation, here like by pi t, conditional on information set. And this information set can include several measures, as I mentioned, including inflation expectations. So formally, as I said, trend is the infinite horizon forecast. So basically, like this tau t is the expectation of inflation far ahead in the future, conditional on an information set. It absorbs new information. So once we go from t minus 1 to t, and we incorporate new information in our information set, we update this inflation far ahead in the future. So you can just think about like the trend yesterday, the trend today minus the trend yesterday. This brings how the new information was incorporated into the trend. And the trend is a random walk. It just means that the trend today equals the trend yesterday plus shock. And finally, the actual inflation is this trend plus a stationary component. The interpretation of the model is that think about like in a world in which we're absent of shock, so like this epsilon t equals 0, so the trend is stable. You can think about like pin down inflation expectations and anchored expectations. However, when we have like sizable shocks, so for example, now during the pandemic, these epsilons are large, so the trend drifts away. So if you just look at thinking that the trends of random walk, trend today equals the trend yesterday plus an error. So this shock, when these shocks are big, there's the risk of de-anchoring. So it's a very simple and straightforward model. The observable variables that we use in our information set, first, we inform it by past inflation. So these are actual inflation rates, which we're looking at changes in CPI and PCE indexes, and also of the GDP deflator. We inform the model with trimmed mean measures, the ones from the Cleveland Fed, which are median and trimmed measures of CPI and PCE realized inflation. And then from surveys. We have here forecasts of future inflation from the survey of professional forecasters, from Blue Chip, and the consumer service from the Livingston. Our baseline model is for the period from January 2000 to March 2022, which is basically like a period of more stable inflation expectations. And we do like a robustness check going back to January 1960. So this is how it looked like as of March 2022. This is basically the results that are on the online version of the note. And you can see that like the trend inflation before the pandemic was really like fluctuating around the sample average, which was about 1.7 to 1.8%. Oh yeah, and this is the core PCE trend inflation. Okay, so the figure on the left is the level, the figure on the right, the standard deviation of this series. So it was quite like stable around like 1.7, reaching around like 1.8 before the pandemic. And then there's just like notable decline right like on the onset of the pandemic. But what we have been seeing is that this substantial rebound during the recovery, and this has been like much larger than actually the drop in inflation that we saw after the pandemic, with like as of March 2022, this trend inflation reaching around 2.2%. But but not only like the level is high, but also the uncertainty around this measure is quite high. So the figure on the right shows like the standard deviation of this measure. We're thinking about like that shock component of the trend. This also increased quite substantially compared to the average over time. What does this mean is that the level is high, and if uncertainty is high, it also fluctuates a lot. So we have less confidence on the actual level of this trend inflation. As of March of 2022, we did a counterfactual exercise. We did a stress scenario. The idea was that, okay, let's take as the next 6 months as of March 2022 as data with a scenario in which inflation expectations would deteriorate considerably. So basically just calculate 2 standard deviation over the inflation expectations, and we add that as data over the next 6 months, or we can think as like a 2 standard deviation increase in the expectation of inflation. And what we saw in this red area is that not only the trend would increase, but also uncertainty would remain high, which is like this prolonged increase in trend inflation and this high uncertainty would bring some risk of de-anchoring, both on the level and also like on the uncertainty scenario. The next to try to understand a little bit if like, okay, we have all this the model, like a bunch of like variables informing our model, but how important are actually inflation expectations to our forecast? We performed a horse race over 4 models. So the first one is the naive model, as we call the past inflation, is a model in which we do not take any information from trimmed measures or surveys. We only look at our trend is only going to be informed by realized inflation rates, CPI, PCE, and GDP deflator. The second model, we forget about past inflation surveys. We're only looking at trimmed mean and median realized inflation, the Cleveland Fed measures. And the third model only includes surveys. So we're only taking signal from, you can think of very forward-looking model in which we're only looking at forecast and expectations from surveys. And the fourth model is our baseline, in which is our all-in, in which we put all sorts of measures, realized inflation, trimmed mean, and median measures. We do that for 3 sample periods. One of a full sample from January 1960 to March 2022. One is just the second one is just for the before 2000, and another one which you call the recent periods is from 2000 onward. So what you're seeing here, let me first explain a little bit what is this table. These are root mean square errors and ratios, so divided by each one of the subsamples. We take as a benchmark the naive model of past inflation. So when you see like in white, those like percent, those are the root mean square error for the model of past inflation. And all the other models are a ratio of the root mean square error of that model divided by the past inflation. So what it means is that if the model has an indicator above 1, it means that it performs worse than just using past inflation. If it's below 1, it means that it performs better than just using past inflation. So there are 3 main takeaways from this figure. The first is that the forecastability of all models, they improved in recent periods. So if you look at the last 3, the last lines here, they're all like this. Green is better, like red is worse. You can see that all models, they are performing better than this simple naive model in which takes information from past inflation. It doesn't matter if we're forecasting 12 months ahead, 36 months ahead, or even like 5 years ahead, 60 months ahead. The second is that the survey measures, they are useful in recent periods, and this is basically like I think of what Marta was asking to see if like how surveys were performing nowadays. You can see that like surveys didn't really perform or didn't add much to the over the model simple naive that look at past inflation during the full period, or even like previous to 1999, but in recent periods, in the past like 20 years, surveys, they do improve quite substantially with like indicators way below 1 over simply looking at past inflation. And the third takeaway is that our baseline, which is the one that it's our kitchen sink model, in which we put like past inflation, trimmed measures, and surveys, this model performs the best. Over just like individual models in which just past inflation or trimmed or survey measures. Just to finish, I updated this model with recent data. So what you're seeing here are the results as of November 2022, or like as of last week. The increase in the trend seems a little bit more sustained. We've seen the trend reaching about 2.6%. Again, this is core PCE, trend inflation, and uncertainty has also increased quite substantially, which means that this trend ended up like moving much more than before, or than like the pre-pandemic. So and one last thing is that both the trend inflation and uncertainty, they are even higher than in our counterfactual exercise that we performed back in March. So just to conclude, the statistical model provides a useful statistical models, like they provide useful frameworks to estimate and track underlying inflation, as for example perceived by economic agents and forecasters. Forward-looking elements that coming from survey forecasts, they bring important signals about trend inflation, and this is like especially during the current episode and this past 20 years. And yeah, like the trend inflation remains higher than its pre-pandemic, very low levels, and uncertainty around it is elevated. Thank you.
Thanks a lot, Danilo, for that. Some comments in the chat are about all this information that we seem to get from many studies about usefulness of expectations across type of agents. No? So in a pooled econometric horse race exercise, you find that like professional forecasters and more or less expert in forecasting get some information value, but actually when you have turning point, nonlinearities, or you suspect change in regimes, then you need to dig back from other agents like consumers and see where you get value. So where are the pits and the pros and cons of different type of activities and the risk of being racially inattentive? Marta, would you like to take some of the comments?
Thanks a lot for the questions, and by the way, also for the answers that already presenters that came after me gave to some of the issues that I raised. So from what I saw in the chat, one question was about a model that consistently outperformed during the recent period. So basically starting with COVID. Which model was that? So this was based on VAR, including short-term survey expectations. So survey expectations, so SPF expectations 1 year ahead, essentially. And actually, I didn't spot it before, but it's interesting because. So we essentially tried to look at, like, you know, which methods or which expectations help in which periods. And it seems that there are some periods where it's more important to correct the trend inflation in the model. So then the long-term surveys would be more useful. But it seems that indeed the latest period is more where maybe, well, at least from the results that we see in our exercise, that it's actually more important, sort of like, you know, what is happening over more medium term as compared to long term. So this is like, you know, sort of where a model is struggling the most. There was a question on how large beavers would compare to models incorporating SPF. So I assume, like, you know, like the background to this question is, if we have a small beaver, maybe, you know, it simply omits some predictors, so it's not as much as the expectations themselves, but about the predictors that they otherwise rely on. And I had a quick look at the table in the paper. So in fact, a large beaver does worse than the model pool. And also there is improvements in tilting also large beaver. So in other words, it seems that there is still some additional information in the SPF that is not contained in the large beaver. And finally, another interesting question was whether we could improve Eurosystem forecasts by, like, you know, including on top of those that already have some judgment, further including the expectations from the SPF, for example. So this is a very interesting question. And there is one practical difficulty here, is that the timing issue. So the SPF doesn't have, like, you know, the same timing as our projections. So in particular, it comes around 1.5 months earlier. So it's very difficult to compare it in short term, because either way it would have much less information than the projections or much more information. But one could maybe try to see indeed what happens in the medium term. Another thing is that I guess, like, the objective of the SPF respondents is to have, like, you know, the best forecast of inflation, while projections are a bit more complicated. So they take into account assumptions, for example, what regards the oil prices, exchange rates, interest rates, which might not be, the best forecast, but still, the path in projection is conditional on those. So that makes also this kind of comparison a bit difficult. So yeah, I would have to think about it carefully, what makes sense. On a general question, whether some type of expectations are particularly useful right now. I mean, the difficulty that I find now is that the period is so short. So, one has to be careful not to overfit. And with that, yeah, let me give the floor to other presenters.
Thanks a lot, Marta. Please, Randal or Saeed, you want to weigh in?
Right. Thanks, Matthieu. So thanks for the questions. I'm just looking at the chat, and first responding to Ernest's question. Thanks for your question. And so my sense is that the professionals are always attentive. Most of these professional forecasters are, economists employed in the private sector, and it's their job to be producing good forecasts. So they have an incentive to be always attentive. So for example, let's take, I think the fact they are always attentive is hurting them this time. And the reason is, for example, over the past 1 year, they have been, we know that they pay attention to central bank communication. And just like the central bankers who were expecting high inflation to be transitory, this was the narrative that they also took it very seriously, because I was very closely following their narrative. I was involved in forecasting. So for this inflation period, I'm pretty certain they were giving a lot of credibility to the central bank's communication. Hence, just like central bankers missed this high persistence, continuing persistence in inflation, so did they. And why this miss was there? Because it was the story. The story was that we as central bankers collectively were thinking that the supply-demand imbalance would resolve more quickly than what actually occurred. And the professionals their narrative, looking at the blue chip over the months, was very similar. However, households, when they do pay attention, I mean, they don't spend too much time. There is research out there. They look at other products like the price of milk, the items that they do purchase more often. Milk was one. My colleague Matthieu at the Cleveland Fed a few months back had a commentary in which they did this, empirical examination to see which particular items drive household expectations, and milk was one of them. Energy prices was another. So when they become attentive, they are not looking to the central bank communications. They are making their informed judgment about the prices they are seeing. Hence, they will see that those high prices, and they will translate into higher expectations. And then also there was another question in the chat that, yes, I think that's the thing, is they are biased. Typically, they are biased upward. And I think it's the luck is there too. So they typically, households respond much more than professionals or businesses do. And because this time inflation was persistent, and the fact they do respond more strongly to price movements, especially when they are to the upward, they were lucky that they did get it right this time. And looking in the 70s, that was the case too. Households were moving much more quickly, responding more strongly than the professionals were. So I think it's a long response, but so I think this is a response. I'm not sure if I'm missing something else in the chat. If I'm doing, please, Matthieu, let me know. If there are other questions, please do let me know. Before I end, one other thing I wanted to highlight from this new work is that although in the presentation I showed, I just highlighted the prediction power of these expectations 1 year out. But we also, in this new work, we will show that bringing in long-term inflation expectation also help in so bringing long-term expectation in addition to this 1 year out inflation expectations does also help improve our quantile regression 1 year out forecast. But as we go further out, 2 year, 3 year out, we see more of gains from the long run survey expectations. And I think which is consistent with what Marta has also summarized about the usefulness of long-term survey expectations for many different VER models. I will end here.
Thanks a lot, Saeed. So that brings me to Danilo. I think there is one connection to you, which is if there is one thing that central bank forecasts do not play with too often, is excessive volatility in long-term inflation anchors. No? So with your research about how we get indications on when the long-term trend on inflation is moving at odds with perhaps a central bank pronouncement. So any views you would like to share with us on how your work actually is connected to this topic of performance of SPF type and versus agent surveys, please?
Yeah, very quickly. First, we haven't really like evaluated which one of the specific surveys that contributes the best or the worst for our model. This is actually like would be like a nice exercise if this what's basically like dominating the trend coming more from like maybe like consumer expectations or long-term forecast or on the short term. So this would be like a very nice exercise to be done to see what's actually driving. We do see, especially like in recent periods, that it is highly driven by expectations and not that much by past inflation. Those seem to be the ones performing the best and even better in longer runs, so like 2 to 5 years ahead. And on also like coming from other questions on another good example would to a good exercise would be to check some state dependency during periods of like recessions and non-recessions to see if there's some sort of like ratio in attention to see if like the surveys are really driving more like during periods of recessions or in periods of high inflation, not necessarily like of recession or not. On the uncertainty part, this is like one of the nice feature of the model is that we can actually have like a directly observable way of measuring uncertainty around the trend. So basically what we've been seeing is that yes, the level is high, but the confidence of on this level of trend is low, which means that like our measures of uncertainty they are high considered like to historical perspective, more than double the average, which means that the trend inflation can go either way, can go up or down like very like quickly. So they have like this large swifts around the trend.
Thanks again for the three presenters, very interesting presentations, and for the activity in the chat. It was very most welcome. And then I would now pass the floor to my colleague Alessandro Notarpietro from Banca d'Italia for the next session. Thanks again, everyone. Bye.
In the next session, we're going to dig a little deeper into inflation forecasting and exploring new avenues for improvement. This is going to be an interesting session. You'll see there's a lot of new techniques, and it's an interesting blend of central bank, let's say, policy institution and academia. We're going to have Andreas Joseph from the Bank of England, and then Massimiliano Marcellino from Bocconi University, and finally Dalibor Stevanovic from UQAM. So without further ado, I'll give the floor to Andreas Joseph from the Bank of England, who's going to present his work on forecasting UK inflation bottom-up. Please, Andreas, the floor is yours.
Thanks a lot for the kind invitation. It's really, I think, a very great and timely event, and also a good lineup in terms of topics, methodology, like a very good breadth. The usual disclaimer applies that I speak only for myself and not for the institutions. All errors are. In a sense, like what we are doing here is like we use, as the title suggests, we use microdata to forecast headline inflation like headline or aggregate inflation indices. This can be headline core, service core inflation, and we basically use the underlying monthly item level consumer price item indices, which we have about say roughly 700 at any point in time, as a mixed amount of macros people would do, and then part of the novelty together. So I have just a message here on the from WebEx. Part of the say novelty of the paper is that we combine this high dimensional data with different types of model which actually can deal with this dimensionality effectively. And there's like dimensional reduction techniques like dynamic factor models, principal component regression, partially squared. Then trinket methods, which some people say, oh, that's like on the transition between classical statistics or standard statistics and kind of new, more catchy, phrasey machine learning techniques like rich regression, lasso, elastic net, and then kind of the universal functional approximator type of models, which is like the random forest support vector machine neural networks. So what's a little bit special about these models? So they're like mostly non-parametric, semi-parametric, and kind of build kind of local approximation of the data generating process based on kind of the data you feed them. The last type of model also is subject to the black box critique that you don't have clear input-output relations, and that some of the can be addressed by using kind of Shapley value decomposition, which are, I think, slowly becoming a standard for this kind of application to make these models more transparent or explainable what they're doing. Sorry, slides forward. Yeah. So we connect to a vast literature, or bring also different parts of the literature together. I mean, of course, on inflation forecasting, using dimensional reduction techniques, for example, dynamic factor models, more newer models like machine learning, but also the use of highly disaggregate data, where I think the paper probably closest related to ours is the one by Ibarra, where they use a dynamic factor, or he uses a dynamic factor model for forecasting CPI inflation on a wide set of indices. So what's the precise forecasting setup? It's basically, as I said, the target are aggregate inflation indices, and our predictors are mostly a set of several hundred micro price indices, which we chain link to get rid of some seasonality in the data. And we have them available for roughly a little bit more than 20 years now. So at the end of the period, there's a little bit of COVID, even so we don't have very much results on this there because of the shortness of the period, to kind of have a big trade-off between the richness of the data set, but also the information we can actually use and put in our models. We use 7-year rolling windows approach. Why I said like it's a trade-off, because the longer you make this window, the few years you can actually use, because the changes, due to the nature, the change of the aggregate indices or the composition of the indices. But we capture with this approach about 70% or 69% of the index series, item series on average. We take an AR2 as a benchmark, and we do a so-called like a two-step forecasting approach, which makes it easy also to kind of differentiate the kind of contribution from new data or new models relative to the benchmark. By say first using the benchmark to forecast, and then using the first step residuals as the target, and the second step for using new models or data. So just to give you a little bit of an overview of the data. So we follow this kind of classification of items and indices or groups, individual consumption according to purpose, COICOP for short. And you all know we often all know the kind of aggregate indices like headline core, service core inflation, for example. And then you can go down and say, like, for example, for food, you go food, fruits, veg, chilled fruit, and then there's apples, and then apples in different stores, different type of apples, and so on. And if we talk, for example, of apples, that's, for example, an item which we then ultimately using in our model, and we have about all in taken together with over 1,000 such series over the whole time period. So when you will look then at the kind of and many people who work with microdata will probably see such a distribution be very kind of typical. This kind of, if you look at the distribution of the microdata, for example, all kind of year-on-year changes of this kind of price indices, it can be described as being so-called leptokurtic. This means they have a very sharp peak and very wide tails. So it's different from say more normal distribution, which would have like a fat peak and very slim tails. But kind of the center of the distribution is kind of fairly unbiased, which corresponds to the median or mean of the kind of aggregate indices. So this means there's some informatives there. And when we look at the temporal distribution, we see something similar. Again, like you see kind of here the orange line, the median of our data, which then corresponds mostly kind of well with kind of the median of our chain length indices. But again, by the interquartile range, you see a little bit of kind of the wide range here. So let's fast forward because of the limited amount of time to the kind of results. Let's first look here at headline inflation using only items. Item series means like without macro data. And you see here on the kind of lines, different groups of models. And so here's the kind of penalized regressors, here the machine learning models, different time horizons, different targets, headlines, CPI, service, and that's all relative to our benchmark. This means numbers below 1 are better than the benchmark, and if they're kind of thick and with stars, then also significantly better. And what you can see is a little bit of a sobering results here, that basically on average, kind of adding indices or different types of models does actually not lead to much improvement relative to the AR benchmark. And when we move forward to say to including macro series, it actually gets worse. And if you take only macro series, like something more conventional with kind of different types of model, we again get some improvement, but overall it's say probably not that great. But then I mean one could rationalize that actually, as you already saw in the previous presentation on what's about the tails of the distribution, when we take, for example, disaggregate, for example, expectation data from consumers, for example, that there's a lot of information in item series which could be picked up in the model about particular times of the kind of aggregate series. And we look at now more specific at kind of performance of forecasts over different time horizon. For example, when inflation is high, it means in this case above 3%, low, below 1.5, or in interquartile range, and definitions for rising inflation, falling inflation, or if it's neither of the two, then stable inflation. And when we look at similar results here, item series plus macro indices for headline inflation, where I only show results, so you see consistent improvement or like a significant improvement, I want to say, over different time horizon. We see actually that for the tails of the distribution or turnings, like meaning falling, rising, high, or low inflation, I would argue particularly kind of penalized regression models can lead to sizable forecasting gains of say 10 to 20%. Some improvements for the kind of machine learning models, but mostly I would say penalized regressions on longer horizon. We see say less strong results for core inflation. Possible explanation may be because some of the kind of it's less volatile in the first place, so maybe then the actual approach for high and rising and so on, expecting more is less there. Yeah, than some of the more volatile series, which probably provide a lot of information, are also not in there. But we see again somehow similar results for service inflation forecasts. So now I've showed you something that it can improve on certain kind of tail turning points event, like using microdata or machine learning models. So how much time do I have just for
2 minutes?
2 minutes, okay, that's fine. So the kind of dimensional reduction techniques, the penalized regressions, they actually are fairly transparent models because they're linear, but the kind of machine learning models are not. So this means like what we go to make them a little bit more transparent, and we can do this actually for all models. At the end is use the so-called Chapter decomposition, which is I think a fairly accepted decomposition of machine learning models now, which have some nice mathematical properties. So basically we decompose every model prediction in all the kind of input components, means all individual item series, and then we reaggregate them to certain kind of macro or macros, may argue, meso kind of components, for example, core goods services and volatile goods services, such that one have a little bit of a more granular view of the model is doing. I skip some of the technical details just for the interest of time and go straight to the results. Basically, what we see is the ridge regression, and similar for other penalized models. They have a fairly stable allocation of, say, you see here over the forecasting horizon, for different targets. We see here the ridge, so to say, is fairly stable. The kind of shares are allocated to different groups. For example, core goods, foods, a little bit volatile, energy, volatile core services, and more volatile services, and macro data. And these are, so say, for example, mostly allocated to core goods, for say classical, let's say, inflation, say components. Some think of things you buy in a shop, so partly in a shop, probably not a supermarket. And then the Shapley share for on the bottom line for kind of random forest, we see here it's less stability, and and that's something I think provides more. I mean, on the one hand, it provides more information. On the other hand, of course, it raises a little bit more question about the kind of usefulness or stability of the model, and that's something we currently looking further into. And I skipped this slide because I want to come to the wrap up of my presentations. So we find in total, using micro data, we can find sizable performance gains and forecasting inflation around turning points in the tail of the distribution. Overall, we find fairly weak results, say, including all inflation periods. Model comparison penalized regression seem to be most promising this approach. We use Shapley values for decomposing the more black box models, and coming a little bit to the kind of more instability of, say, especially the machine learning case, the allocation of say model information to different groups and what we can learn out of this. I mean, one takeaway also, because we tried a lot here, it was quite difficult to reconcile certain micro information from the data with macro outcomes in a consistent way. So this kind of storytelling is actually quite much more challenging than I think one would like to have it as a modeler in this kind of setting. So with this, I say thanks. Just a short shout out for people who are interested. There's currently an open call of the special issue in the Journal of Econometrics, Machine Learning for Economic Policy. So take a look there. The deadline is still half a year out, so you can write a new paper on this. Thank you. Thanks for having me.
Thanks a lot, Andreas. Thanks for the very interesting presentation. The next speaker is Massimiliano Marcellino from Bocconi University. Massimiliano, please.
Thank you so much, first of all, for the invitation to this great workshop. And I'm very pleased to discuss this paper on forecasting US inflation with Bayesian parametrics. The usual remark apply. We forecast inflation, and we know that forecasting inflation is a pretty difficult job, as we have seen in some of the papers that were presented earlier. And actually what you will see is that this paper is linked to a lot of the stuff that we have seen so far. So for example, the presence of inflation states like high and high inflation, the relevance of nonlinearities, the role of inflation expectations, what happens in the tails, and so inflationary risks, the role of heteroscedasticity, stochastic volatility / uncertainty, and so on. And in line with what Andreas just presented, while a lot of the papers that focus on forecasting inflation are linear and parametric, there is a growing literature instead on working with non-linear and non-parametric models, mostly borrowed from the machine learning literature. And so there are papers on the work with random forests, there are papers on neural networks, and so on. And so what we do in this paper is take a similar approach. Those, as you will see, this is even a little bit more general, and it is in a Bayesian context rather than in a classical one. So it's also relatively easier to get density forecast for inflation and so on. And, you know, when we work with these machine learning methods, there is often the issue that, you know, you allow for a lot of flexibility in the specification of the conditional mean. So in FXT here, but typically borrowing again from machine learning, epsilon t is supposed to be IID, and also often with a Gaussian distribution. And so another issue that we try to address in this paper is instead, you know, to make it a little bit more balanced, and so to work with a flexible specification for the conditional mean, but also with a very flexible specification for the error term, okay? So what we do, again, we build this very flexible model, non-parametric model, and then we apply it to predicting inflation in the US. And we will build on a statistical tool that is called the Gaussian process regression that I will try to introduce first. And then again, and this will be mostly the tool that we use for the f of xt part, so for the general non-parametric specification of the conditional mean, while for the error part, and so for the epsilon t, we work with the Dirichlet process mixture model, which basically means, as you will see, that we model epsilon t as a possibly infinite mixture of Gaussian distributions, okay? And then again, we apply to US inflation, and we focus on point and density forecast, because this is the key business, but we also focus specifically on tail predictions. And so the idea is, again, to understand whether working with these more sophisticated specifications is particularly useful in specific quantiles of the predictive distribution. So I will not manage to cover all the material. Of course, there is a paper available, and the slides have many more details, so I will only focus on the main ones, but for those that are interested, then the full slides will be posted. So again, I mean, why do we need more general specification for the error term? Because if you try to plot the residuals, typically the residuals are non-Gaussian. And why do we need nonlinearity? Because again, in this kind of plot that shows the coefficient that you would get in a kind of Phillips curve, it's clear that you get quite a lot of movements in there with sudden jumps and stuff like that. And so what could you do? Well, you could either go with a kind of parametric specification, and so work with threshold models like those that we have seen, or maybe Markov switching if you want to be non-general, or you know, even more sophisticated parametric specifications. Or you can basically try to be even more general. And so, as I was telling you, try to non-parametrically assess the relationship between your target variable y, that is inflation, and a set of predictors x. And a little bit in line with what Andreas was presenting before, here we would like to have x of different dimensions. And so we will compare models for US inflation that include only the usual suspects, so like lagged inflation and a few predictors, an intermediate set of predictors that has about 20 variables, but also a very large set of predictors that has over 100 regressors. Again, just to show you that this machinery that here we apply specifically to inflation is actually of very broad applicability. So what is the problem here? The problem is that you believe that the relationship between y and x is characterized by this function f, but you do not know f, okay? And so the point is, how do we learn from the data about f? And so, of course, the easiest thing would be to assume that f is just linear, but here we want to make it more general, okay? So let's start discussing how we treat f, and then we discuss what we do for epsilon and so for the error term. So think about a traditional Bayesian model. Imagine that it is linear, so yt is equal to xt beta plus epsilon t. So you assign a prior on beta, okay? So here we have this different model because yt is equal to an f of xt plus epsilon t. And so what we would like is to assign a prior on f. But this is a very messy business, right? Because f is a function, it's not a parameter, and it's an infinite dimensional object. And so the interesting question from a statistical point of view is how do we assign a prior on an infinite dimensional object like the f function? And again, here we borrow from the statistical literature where you typically do this. So you assign a prior on a function by working with what is called a Gaussian process regression. And so what do you do? Well, you know, you would have like an f of x1, then you would have an f of x2, then you would have, you know, an f of xt, and here this t is going to infinity. And so basically you model the distribution of all of these f's, and you do it with what is called a Gaussian process. And so basically this Gaussian process prior implies that you have a Gaussian distribution on all of the f's that you are trying to model that in this case has a zero expected value, but this can be generalized if you look at the paper, and it is characterized by what in this literature is called a kernel function or a kernel matrix that basically gives you the covariances between the elements of this unknown f function over time. Okay, and so these Gaussian process priors are fully non-parametric, and you do not need to make any assumption on the form of f. Okay, and again, you can think of them as basically priors over an infinite dimensional function space. So how about this kernel? So how do you choose kappa? So there is a lot of literature on this in non-parametric Bayesian statistics, and it turns out that different choices of this kappa function can give you very different types of models. So some choices of kappa, for example, generate Bayesian neural network models. Other choices of kappa can give you models with jumps in the parameters. So what we do in this paper, which is really a kind of appetizer for those of you that want to learn about these beautiful techniques, is go with the most classic choice for the kappa kernel, which is just a Gaussian kernel. And the beauty of this Gaussian kernel is that it is extremely parsimonious because you see that it only depends on two parameters, this psi and phi. And so you see that basically if you fix t is equal to tau, basically this kappa becomes the variance, if you wish, in quotes, because we are talking of functions. And you see that this becomes just equal to psi. So basically this psi parameter is representing your prior views on how much variability you have on the f function. How about phi? Well, you see that phi amplifies the effects of this distance between xt and x tau. So in this case, we have a quadratic norm. And so basically, the larger is phi, the more flexible your function f can be. So basically, if f increases, your f function becomes, let's say, more nonlinear. Okay, and you will see how it works in a little bit. And so the point is, if you look at the paper, then you have to implement this machinery. And so we have a kind of MCMC algorithm with a few metropolis Hastings steps that are used in particular to generate posterior distribution for these two key parameters. And you will see that this machinery scales very well in the number of regressors that you have. So in K, again, you can do it with hundreds of regressors and it works. It's a little bit more time consuming in the number of observations, and this is because of the structure of the problem, but still, you know, it runs in just a few minutes, even in a recursive context. So, well, let me skip this slide because we have little time. Let me just show you a very simple example. So imagine that you're modeling inflation using the lag of the unemployment rate. And so with the idea that, you know, if the unemployment rate goes up, inflation should go down. And so in this case, we fix, let's say, let me call it the variance parameter xi, and I want to show you the effects of this phi that you remember is what is controlling the extent of nonlinearity in F. So on the left panel here, you get priors. And so the red lines here are draws from the prior, so the fit that you would get from different draws. And the dots here are just realization for the US on inflation on the left axis and unemployment rate on the right axis. How about the posterior? Well, you see that if this phi is very small, basically you get a linear F function. So this would be your F hat, and you see that it is pretty linear. So it's negatively sloped as we expected it, and it looks like this. And of course, you also get the bounds around it. How about increasing phi? So you see that now we moved from 0.01 to 0.1. We keep psi. The psi here, we keep it fixed. So you see that overall variance, so this range remains fixed because this is controlled by psi. But you see that now you start getting flexibility, both in the priors, but even more in the posterior. And so if you keep increasing phi, you see that, you get an estimated function that becomes quite highly nonlinear. And so, of course, here you can think that there is the risk of overfitting. But again, keep in mind that here, the risk of overfitting is pretty limited because you are playing with just two parameters here, okay? And in addition, we will control overfitting by also allowing for a general specification for the error term. Let me skip this part that we will come back next. So how about the error term? So as I was telling you, for the error term, we use this Dirichlet process mixture. And basically, the idea is that your epsilon t here is a mixture of Gaussian distribution with different means and variances, and it is possibly an infinite mixture. And so here the trick is, of course, to make this feasible, and so to approximate it with a finite number of states in there that here I'm calling J. And again, if you look at the paper, there is a discussion of how to choose J and how to assign priors on the weights that you use, okay? And then, of course, there is the description in details of the algorithm to estimate this machinery, okay? And so, as you will see, if you look about this Gaussian processes regression, one way to think about this f of xt is basically as an infinite dimensional weight of Gaussian distribution with different means and different functions. And so basically this Dirichlet process mixture that we use for the errors is the counterpart of that. And so this is more or less as general as you can get. So you have an infinite mixture for approximate the conditional mean in each time, and an infinite mixture to approximate the errors in each time. Okay, so let me skip this. So let me just show you how this thing works with simulated data, just to give you an idea. So imagine that you have this pretty messy function here. So here, kappa, I think we have 20 or 30 in this simulated data. These x's are IID normal 0, 1. And this is the way that they affect the y variable. So basically your fx, in this case, it has a linear part and this highly nonlinear part in there. And the error term in here, it is drawn from a t distribution with very few degrees of freedom, okay? And so this can have a lot of probability in the tails. And so here you see just a draw from epsilon t. So the black lines are draws from the distribution, and the red line is the fit. And so you see how basically this Gaussian process model that we suggest does a pretty good job at estimating f of x, but you see that it also does an extremely good job at capturing the outliers that are generated in the errors in this case. And so, for example, this machinery works pretty well to capture the outliers that we have experienced during the COVID period, okay? Okay, then very briefly on the application.
Silviano,
yes.
You have one minute more.
Okay. Yeah. I will skip this. So I was telling you, different sizes of the data sets, forecasting inflation, and the core inflation results are in the robustness. And basically, you know, we take as a benchmark either linear models as in the previous paper or the unobserved component stochastic volatility model. And this is just the summary of the results. And again, as you will see, in particular, if you look at the additional slides that you find in here, this machinery is really doing a pretty good job. And it works decently well. I mean, comparable to the UCSV or better in the center of the distribution, while it does particularly well in the tails. And it works specifically well in the left tail, so for relatively low inflation, while for right tail, it seems that you really need to add additional information, which could go either in the form of the microdata that Andreas was suggesting, or some of the indicators that Dalibor will present in the next presentation. And I would like just to finish with this slide that gives you an idea of what are the drivers of these results. And again, it links with a lot of the stuff that we have seen before. So for example, here, inflation expectation are the 1 year ahead survey of professional forecasters. And you see that 1 quarter ahead, there is very little difference in their coefficients across all the quantiles. So 5th, 95th, and so on. While you see that these forecasts become much more relevant 4 quarters ahead and exactly when inflation is very high. Similarly, you see how the PPI becomes particularly relevant in the right tail of inflation, and so when it's very large. And you see the lagged inflation is kind of relevant, in particular in the left tail 1 quarter ahead, but it is completely absent from the right tail. And then again, please have a look at the paper if you are interested in getting more details, and thanks a lot for giving me a chance to present the paper.
Thanks a lot for the insights about this new method. And without further ado, Dalibor, you're ready to go.
Good morning. This is a paper with Massimiliano. It's about the demand and supply of information about inflation. Since 2021, we seem to be going back to something similar that we had in the 70s. Okay, so that's why we all now think about inflation and mostly about inflation expectations. Okay, so next slide, please. Yeah, you can move it at the end of the slide. Yeah, okay. So what we do with this paper, well, we try to figure out whether the market of information about inflation can affect the future inflation developments, but overall we're trying to see the effect on inflation expectations. Okay, so the proxy for the demand of information about inflation will be the Google Trend. So we go on Google Trends website, and then we can take the time series for keywords such as inflation, inflation rate, price increase, whatever. It turns out that, you know, the simplest one, which is inflation, is the one that has the most information about that demand. So the rationale is that when agents are more interested about inflation, well, I mean, these days they're gonna look at the Google first. The drawback of this is that Google is, I mean, this Google Trend is available only since 2004. Okay. On the other hand, the proxy for the supply of information will be an indicator constructed from the Wall Street Journal article. So what we do is we take the title of for the same time period of the articles published in Wall Street Journal, and we check how many of them contain the word inflation in the title. Okay, and then the rationale there is that when agents are more interested about inflation, well, the journalist will write more about it, and doing this text analysis on the Wall Street Journal is a natural source. Okay, and there are other measures that you can think of. For example, a related paper by Angelico and co-authors, they try to measure consumer expectations about inflation from tweets. Okay, so next slide. So the following, well, let's go to the next slide. Okay, so graphically what you have is the following. So on the left you have the history since 2004 of the CPI year-over-year inflation against the Google Trend same in year over year. And on the right, you have the CPI and the Wall Street Journal index. Okay, so we see that they seem to be fairly correlated. I think the correlation is about 0.5, 0.6. They are not only correlated when the inflation is going up, but they are also correlated when inflation is going down. So these are the interesting periods. And now what we want to see is whether this correlation is is by chance, or there's something more causal that we can say about it. Okay, so next slide. Now we see, now we add to the previous graph, we add the measures of expectations. So you have the measures of the SPF. Okay, but we also will look at the monthly ones. Okay, next slide. You can go further. Okay, so the empirical analysis. So there are essentially 3 or 4 empirical analyses, but they all try to see, how the information market will affect the formation of inflation expectations. Okay, so to provide the formal evidence, we start by projecting inflation expectations on the demand and supply information indicators. So we try to figure out what is the explanatory or predictive power of those measures. Then we more formally test the full information rational expectations, by projecting the implied forecast errors on those indicators. And what we find is that both Google Trend and Wall Street Journal have a substantial and significant explanatory power for the various measures of inflation expectations, and those are the survey professional forecasters, Michigan survey, Atlanta Fed survey on business expectations, and New York Fed survey on consumers. And we also find that the full information rational expectation hypothesis is often rejected, which suggests that some informational rigidities exist and are waiting to be exploited. Next. Okay. Then after doing that, we carry out a structural VAR analysis. So what we find is that a positive shock to the Google Trend or to Wall Street Journal will induce an increase in those measures of inflation information, but they will also induce a significant increase in inflation expectations and then in the CPI inflation. So there seem to be some channel transmitting the shocks on the information market to the CPI inflation, probably through the formation of inflation expectations. Okay, and then finally we also do a pure out of sample forecasting exercise in which we try to forecast several measures of inflation. So we do for CPI, for core CPI and PCE. So we take many different models, even the data-rich models, with and without measures of information. And we find that most of the time when you add Google Trend or Wall Street Journal, it will improve the out-of-sample forecasting performance. Okay. So I will not have time to talk about all of it. So let me just show you at least. So can you go back one? Okay. So so I mean, what's interesting here? So is to try to think about the transmission mechanism. So we believe that the one that is interesting here is the expectation one. Okay, so the way the agents will form their forecast about the future inflation. So the empirical strategy to test this prior is to project inflation expectations or the implied forecast errors onto demand and supply information indicators. So that will be the first step. In the second one, we explore causality channels through the VARs, and then we do this out of sample performance analysis. So some notation. P, T plus H given T is the forecast H periods ahead. So this will be a measure of inflation expectation. Then PT plus H is the realization. The difference between the two is the forecast error. And when you see Z in equations, well, that's the vector where we put the Google trend and or the Wall Street Journal given at the time T. Okay, next slide. So the first question is whether the Google Trend and Wall Street Journal can explain or predict inflation expectations. So what we do is that we project the expectation at time t on its own past on the Google Trend and Wall Street Journal, and we might add some controls. Okay, so in those controls we can put the current inflation or the current signal of inflation, the gas price or the gas inflation, the food part of the CPI, and this indicator which is the global supply price chain price index. Okay, so the null of interest is beta equal to 0. So we want to test whether the information market has some predictive or explanatory power about those expectations. So if the null is rejected, well, then that means that those demand supplies are informative about the formation of inflation expectations. The expected sign of beta is not clear, but we can believe that it could be a positive when inflation is high and negative when it's low, but still it's not very clear. Okay, next slide. Then the second set of regressions is concerned about the full information rational expectations. So how this is usually done? Well, we construct the forecast error we put it on the left hand side, and then we project it on some function of the information subset available to those forecasters at time t. Of course, we have no idea what their informational set was, so that's why we can try many observable signals that could be that could represent their information set. And a famous example of that is in Koivu-Gorodnichenko, where they put on, so the left hand side is always the forecast error, but then on the right hand side they put the ex ante mean forecast revision. And in this, well, this setup is motivated by rational inattention models. So then in fact you can map this.
Dalibor, I'm sorry, you have 1 minute to wrap up.
I have 1 minute, already 1 minute.
Yes.
Okay, let's go to the next slide. Sorry. Okay, so this is the, let me show you this one at least. Okay, no, go ahead. So this is the data. Okay, let's see some numbers at least. So here what we do. So this is the ADL, the first regression. So we try to explain the SPF expectations. So what you want to look at are the beta coefficients, so beta GT or beta WSJ. So we do it for the nowcast, 1 quarter ahead forecast, 1 year ahead forecast. And so in case of the SPF, Wall Street Journal is usually the most important one. So it explains significantly the formation of those expectations. And then can you go move further to I'll tell you when to stop. Just keep going. Keep going. Stop. Okay, just before. I will conclude with that one. Just before again. Go back one. Okay, good. Let me conclude with this one. So this is a result for the conditional VAR. So this is also a message of the paper. So you have the upper you have the high attention scenario, and down you have the low attention scenario. So what we do is that we fix either the Wall Street Journal or the Google trend to remain high for the next 4 years, or to go back to its historical level. And then we see what happens with the Michigan survey expectations and the CPI. So the dashed line is the forecast, is the standard forecast from the VAR. So that VAR also contains oil price. And then what you see is that if the attention of agents goes back to the historical level, well, that induces also decrease in the Michigan survey expectations, and then in the CPI inflation. And on the opposite, if the attention remains high, well, that implies high expectations and high CPI inflation. So I'll stop here, and then I invite you to check the paper.
Thanks a lot, Dalibor. We move on to the next session. So I'll give the floor to Denise.
Thank you, Alessandro. Thanks to Dragana and Ernest for bringing us together in another timely and insightful workshop. Now, the last session is going to take a deep dive into the supply side, as we heard earlier, which is perhaps one of the distinguishing features of the current inflation episode. We have a great lineup. We have Emiliano Lutini, who's head of Big Data Analytics at the Central Bank of Chile. And we have Mohamed Yildirim, the research director of the Growth Lab at Harvard University. And we have Francesco Corsello, who's a senior economist at the Bank of Italy. So without further ado, Emiliano, the floor is yours.
This paper is about inflation expectations and the supply chain. The motivation to perform this work is, though we know that inflation expectations is a key variable to think about the effects of monetary policy, in fact, we know very little about the formation expectation process, especially for firms. So the question that we are going to be tackling in this article is actually looking in detail about what are the determinants of inflation expectations at the firm level. And to model it, we are going to borrow some ideas from the seminal article of Robert Lucas about 1972, in which we are going to exploit the idea that firms form their expectations based on the information that they receive or the signal that they receive from input prices. And finally, we are going to assess whether there is any correlation between firms' inflation expectations and their actual inflation. So just to look at the data on the left panel, what we see is the distribution of the survey answer over time. The survey asks what is inflation expectation of firms at a year horizon. And what we see is that these inflation expectations correlate very well with actual CPI inflation. This is indeed the case also for surveys that have been conducted by Oevion and co-authors. And also what we see in this survey is that the dispersion in the answers also correlates with the level of inflation expectation. On the right-hand side, what we see is the dispersion of supply chain or the input prices inflation at the firm level. How we do this is that we have a data set in which we observe all the goods that the firm purchases. We not only observe the goods, we also observe prices and quantities, And because of that, we are able to compute like an input prices or an index of purchase of cost at the firm level, of prices, of input prices. And like on the right hand side, we see the distribution over time of this input price inflation at the firm level. And what we see, what is striking of these two figures, is that you observe a lot of dispersion in either of these two measures. So with this at hand, what we are going to do is we are going to try to compute, or we are going to compute, what is the relationship between supply chain inflation or input price inflation over firms' inflation expectations. And how are we going to do that? We are going to run the following regression model, in which on the left-hand side, we have the change in inflation expectation over time. We are going to control for a firm fixed effect. We are going to include aggregate CPI inflation. We are also controlling for the input price inflation. We are also going to include as control the firms like the growth rate of sales by the firm, as well as GDP growth. And okay, and some key issues that I would like to raise about this equation is that so this is a nice setting, because input prices for most of these firms are completely exogenous. So in this manner, we can come up with a sort of like close to a casual impact of the effect of input price inflation over firms' inflation expectations. And let me show you the main result of the paper. So the main result of our paper are these two charts, especially the one on the left panel, in which we compute the impulse response function of the input price inflation over inflation expectations. And what we see is like the important message of this chart of the left chart is that inflation expectation, input price inflation has an effect on firms' inflation expectation. This effect is cumulative over time. It peaks approximately after 2 quarters. On the x-axis are month. And a one standard deviation shock to supply chain inflation implies an increase in 1% in 0.1 percentage point over inflation expectations. And on the right, the plot of the right hand side, what we see is the impulse response function of the CPI inflation. This is something, what we observe is that the dynamics of the response of inflation expectations are different, while we see on the left panel that it gets like it peaks after 2 quarters. In the case of a shock to aggregate inflation, we see that the effect is mostly focused over the first quarter, and afterwards starts to decrease. As for the quantitative differences of the results, we see that the one standard deviation increase in CPI inflation affects inflation expectations by 0.4 percentage points. In the paper, we also address some implications of this result as far as the full information rational expectation model goes. The key insight that you can find in the paper is that mostly our results are in favor of the imperfect information benchmark, and also we provide some evidence that some of the results might be associated even with the fact that inflation expectations at the firm level are not fully rational. To conclude, the paper has a final section in which we go one step further and we try to compute, or we estimate a Phillips curve at the firm level. Let me focus on the last equation here in this slide. What we derive like a firm level Phillips curve, in which we have on the left hand side inflation, actual inflation at the firm level, and on the right hand side we include the measure of inflation expectations, a measure of real marginal cost, and this is an expectation error that it will go to the error term in the regression model. And let me go to the result or to the key result of this part of the paper, in which we find, sorry, here there is a typo. This should be sales price inflation, and this is also weighted average of sales and export price inflation. Yes, these are two typos. But the important part of this section is that actually the measure of inflation expectation correlates with inflation, with the inflation level that firms actually set, and this correlation is 1-to-1. Here we are not going to I mean, what we claim in this part of the paper is that this is mostly like a correlation, because we do not have anything close like to a shock to inflation expectation, such as that we can claim that this is a causal effect. But we are just very happy that, to the best of our knowledge, we are the first that we are able to come up with this correlation at the firm level. And let me conclude. So the key result of this paper is that supply chain inflation informs about firms' expectations, about how firms set their expectations about aggregate inflation, and that we find like a full pass through from inflation expectation to CPI. We find that there is a full pass through from CPI inflation expectation to firms inflation. Our findings are informative of different theories, especially are supportive of the imperfect information benchmark, the seminal article of Luca 1972. And as far as policy implication goes, what we find is that actually the part of the we find that the channel we highlight in the paper can lead to dispersion in inflation expectation. This is a metric of anchoring expectation. Also, forecast disagreement translate into price dispersion, and in part also that our findings support the idea that the expectation channel of policies might be weakened. Thank you very much.
Thanks, Emiliano. So let me pass the floor to Mohammed.
Inflation in the COVID era, age of COVID, like we have seen many different types of events that's happening simultaneously, like the collapse of and rebound in the economic activity in GDP, in international trade. Then we also saw consumption substitution across sectors. We also observed labor shortages and across sectors and countries. And we have, as a result, the highest inflation of the last 4 decades. And then, like the main question is, can the monetary policy be effective in bringing down the inflation? And to answer this, we need to quantify the drivers of the current inflation and the international dimension. Today, I'll be focusing mostly on the drivers of the current inflation in the closed economy in the interest of time. So we will try to mimic the real life of real events that happened in 2021 as much as we can, and we will use a structural model to quantify the inflations. We will have both the coexistence of labor shocks and inflation and the slack. We will have output lower than potential, and so this is not consistent with the all demand shocks. And another thing that we observed in the real data is the timing and sectoral heterogeneity of the shocks that we observe. So for instance, goods versus services inflation, sectoral inflation becoming broad-based and so forth. And in our time period, we will focus on the time between 2019 quarter 4, December, until 2021 quarter 4. So to avoid going into the asymmetric, going into the period that was mostly affected by the Russian-Ukraine war, but also to focus on a time where the desegregated demand and supply shocks were effective. And we will link the sectoral imbalances, labor shortages to demand and supply, and we will look at global and local supply chain disruptions. So before going into the model, let me show you some what we observed in the data. So this is the select the employment to population ratio and headline inflation in Euro area and the United States. As we see that the headline inflation increased, but the labor has not recovered to the levels it had before the COVID era. And if you look at the different types of consumption, like durables, non-durables, and services, we see different recoveries. Like services have not recovered as much in the Euro area for the period that we focus on, but we saw a huge increase in the consumption of durables and non-durables in the United States, whereas the services have not increased as much. And in terms of inflation, we also see a similar pattern. Like the prices for goods have gone up significantly, but if you look at the service inflation, you don't see much. So this sectoral heterogeneity might be addressed. And on top, there is this network underlying this supply chains and industries. So this should be also included in the model. So what's our model? Our model is based on the Bakayi-Farhi model, which was just published in AER a couple of months ago. So it's a two-period closed economy model. There's a Ricardian household with perfect power side, multiple sectors, and so perfect competition, and downward nominal wage rigidity with zero lower bound interest. And we will have three types of shocks. One will be aggregate demand shock, and the other one will be sectoral demand shock, where the aggregate demand shock is like the fiscal policy and the government stimulus that we observed during the pandemic period. Sectoral demand shock will be shift from services to durables and so forth. So that's to capture that aspect. And sectoral factor supply shocks will try to capture the lockdowns, the workers becoming sick due to COVID and not being able to go to work and so forth. So this is like the model in a nutshell. So on the left-hand side, we have the consumption. And for the consumption, basically we have this Ricardian consumer optimizing between the future consumption and current consumption. And current consumption uses goods and varieties. We will work at 66 sectors for the US, 45 sectors for the for the Euro area, and so forth. And in the production side, we will have sector-specific labor, sector-specific capital, which will be combined to make the value-added portion of the production. And these will be combined with an intermediate bundle, which is formed of the goods coming from different industries. So at the end, all these aggregations that I show are going to be done with the CES functions, and we have theoretical results that combine the CES functions, like we can model them economically. So how do we quantify this? For sectoral demand shocks, we looked at the observed expenditure shares changes and used the BA sectoral personal consumption expenditure data for the US, and for Euro area, we used the OECD quarterly national accounts. Unfortunately, we had it for only 3 at the durables, non-durables, and services level, but we projected them into our 45 sectors that we have the data for. For the sectoral potential supply shocks, we look at the observed changes in total hours worked for the US and for Euro area. And for aggregate demand shock, we back it out by looking at the observed CPI inflation and sectoral hours work changes. And this decomposition is through the first order approximation of the model. And we use the US data from the BA-IO tables and so forth. And for Euro area network data, we use the OECD ICEO 2018 version. So what do we observe? So in the next couple of figures, I will basically show you these shocks being applied to the system. So at the left-hand side, we have the model-based inflation, where we have both the aggregate demand shock, sectoral demand shock, and sectoral supply shock simultaneously. So this is gives us an inflation of 9.18, and US observed inflation was 8.47 during that time. Then in the orange bar, we only apply the aggregate demand shock without we assuming the absence of the sectoral demand shock and assuming the absence of sectoral supply shock. With that, we will have obtained an inflation of 6.33, and in the purple bar, we only apply the sectoral supply shocks, where through the labor shocks that we observe, and the observed inflation is 3.08. So 1/3 of the observed inflation comes from the sectoral supply shock. The summation of all these three are not equal to this 9.18 because there are some nonlinear interactions between all these different components that I'm not going to go into detail about. In the euro area, however, we see much higher portion coming from the sectoral supply shock, and at the end we have like close to half of the euro area inflation coming from sectoral supply shock. In the open economy extension, we assumed we try to quantify the effects of the international networks, and model is almost the same as the closed economy, but we also add some trade. We also allow trade between these three countries or areas, let's say Euro area, United States, and the rest of the world. And we look at the shocks. If there are some, we look at the euro inflation, and in the left-hand panel we have the shocks, all international shocks present. In the orange bar, we have the euro area shocks present, and the yellow bar, we have the outside of the euro shocks. And as you see, because of this supply chains, international supply chains, close to 2/3 of the inflation that we observe could also be attributed to supply chain shocks outside of euro area. So let me conclude. So in the global health shock and limited substitutability across inputs, we have supply chain bottlenecks and rising prices. Supply shocks are important, but also demand shocks are also important, especially the aggregate demand shocks, and especially in a supply constrained world, putting demand stimulus give rise to an increase in prices. And we have a network model with asymmetric supply and demand shocks, and this results in sectoral cost push shocks and inflation. And at the end, like these are different takes on our paper that you see. It could also be addressed as understood as a demand shock or a supply shock, depending on where you look at it. And thank you for your attention, and thanks for the organizers for giving us the time to talk about our paper. Thank you.
Thank you, Mohammed. Francesco, the floor is yours.
Good afternoon to everybody. So I'm going to present some thoughts and some data and some empirical evidence about the pass-through of energy prices to inflation in the euro area, and we'll discuss a little bit implication for our forecasting. We didn't see this coming, not with this magnitude, not for so long. The ECB officially wrote that errors were coming from the conditioning assumption, especially from energy prices, most of it. And that, of course, in these exceptional times with this big projection errors, we should complement the forecasts with sensitivity analysis and some scenarios. With very bad stuff, of course, our projections can suffer big shifts up or down, depends what we're talking about. We were used to big volatility, big shifts, big jumps in the price of oil. We were not used to this volatility and these jumps in the price of electricity and gas. So they're very, very, very clear picture of unprecedented movements, upward movements, and high volatility in this sort of big energy components. And of course, this implied that we've already seen in the history of inflation in the euro area decomposing the energy inflation some 10, 15 at most points of energy inflation coming mostly from fuels, but we have never seen 20 or more points of contributions driven by electricity and gas inflation. So this shock is exceptional and is large. So what did we do with a colleague, Alexandro Bracci at the Bank of Italy? We simply started from a super simple VAR model. We did some structural analysis. We estimated this model with Bayesian techniques and with constant coefficients. And I mean, a persistent energy shock of one standard deviation implies a pass-through to food and core inflation in the euro area, which is a little bit lagging, but it is persistent and up-shaped. But of course, this is a constant model. So constant coefficients using the full sample since the beginning of the euro, basically. There are big caveats because with this exceptional, let's say, energy shock that we are experiencing now, we can have nonlinearities at play. We can have volatilities that change their sides. We can have heterogeneity in the transmission, changes in the transmission. We can have breaks. So these estimates point to a pass-through, which is limited a little bit more on food and less on core inflation. But this analysis is a, let's say, lower bound, is a conservative estimate. Of course, using our model, we can decompose food and core inflation and understand how much of this food and core inflation in the euro area comes from the energy shock. So this is basically the effects of energy shock on this food and core inflation. And of course, we can quantify using this model the indirect effects to headline inflation. So headline inflation as a part that is coming directly from energy, and this is what the statistical institutes are saying. Look, 10% more or less of the basket is energy, and then of course with around 40% of energy inflation, you have around 4% of contribution to headline inflation. And then there is, in September, we estimate another 2% of indirect effects coming through food and core inflation. So there is a big bulk of this 10% figure of inflation in the euro area coming from energy components directly and indirectly, according to our constant coefficients VAR model. So, but then there is, let's go a little bit, deepening behind this shock in the euro area, of course. This is our business. Basically, if you look at inflation of these three components, basically all of it, energy components, electricity, gas, and fuel separately, you see that in the euro area, fuels inflation has been generally common for almost the entire sample. Gas inflation a little bit less, and electricity much less. Why? Because of course electricity and gas are subject to national regulations and market structure that are country specific, and of course this provides a heterogeneity. But look at the last 2 years. The last 2 years have been extremely heterogeneous for electricity, for gas, and also a little bit for fuels. Why? Because policy interventions have been diverse across euro area countries, diverse in timing, diverse in the tools, diverse in the magnitude. So the different heterogeneity in policy intervention has brought a lot of heterogeneity into the inflation of energy components within the euro area. And you can see this from let's say, from another angle. If you decompose energy inflation in Germany, France, Italy, and Spain, the largest four guys, you see that it's completely different. Electricity has been strongly affecting energy inflation in Italy and Spain. It is not the case, was not the case in Germany and France for a bunch of reasons that I mentioned. Gas has been strong almost everywhere apart from Spain, that has intervened with some fiscal policy to sterilize the shock. And of course, fuels inflation have been strong in every country, but some countries have mitigated a little bit more. For example, Italy has put in place costly intervention to mitigate the effect of fuels inflation. So you see that, you see how heterogeneous this was also within countries and across components. So with the model, you can play and try to understand if this heterogeneity comes a little bit from a transmission of energy inflation through to other non-energy components. I mean, these are medium posterior, so immediately an econometrician can say, but how significant are these differences? Probably not so much. So you see that there is some difference in the transmission, but it's not really that big or that important probably if you put bands, but the real deal is the heterogeneity in the shock, in the size of the shock, in the timing of the shock. So if you do, for instance, the decomposition of food inflation in energy and not in different countries, you see in countries in which the energy shock has been stronger, as Italy, Spain, the effect of the energy shock, the attributed effect to the energy shock of food inflation is stronger. So it is really probably a size story than a different transmission, but this is a constant VAR model. So there is a big caveat. We will talk about this at the end of my presentation that is coming. So there is another angle that we can take in discussing heterogeneity of this shock. For instance, if we took now with this session of you all know what's a COICOP, so you can divide groups, classes, and so on. So if you take 80 components of the basket, it is a very fine disaggregation that has historical depth until the late 90s. And if you do some correlation with energy, you find that the weighted correlations, rolling correlations of all these components with energy is basically at maximum, at its maximum since the beginning of the euro area. So we have really a contagion of correlations within the basket with energy components. And of course, this pass-through is also, so what we are looking at, if we want to explain a little bit this heterogeneity across components, we can see that food components tend to be, of course, much more sensitive to energy shock. And you see that here, for instance, more than 50% of the weight of food components tend to display high pass-through from energy shock, while core components seem much less. The pass-through is smaller. There are some of them not so big in weight that have a pass-through this comparable or even higher, for instance, air transportation, even higher than food components, but just a few of them. So you see that there are heterogeneities that are big coming from the countries, but also from the subcomponents. So we are basically at the end of the presentation. This is the last slide. So we have an exceptional size, but also an exceptional nature of this shock, of this energy shock, and there can be tons of non-linearities at play. There is a sizable degree of counter heterogeneity because of shock size and maybe transmission, and of course because of different policy intervention. You saw how difficult it is to discuss a common policy intervention, for instance, to price cap, the gas, combo policies. So imagine how diverse 2 years or 1 year and a half of policy interventions we have experienced in the last year and something. So you see there's a lot of counter heterogeneity that complicates things for forecasters. The pass-through looks also different across inflation components. So within the basket, you have different sensitivity that you have to take care of. But the good things are that in the Euro system, we are used to work with disaggregated inflation because we do bottom-up forecasting. So each country provides its own forecast, and each country knows very well the energy market, the energy prices, and potentially also the pass-through of energy prices to other components inflation. So this is good. Disaggregation in this case is good. And of course, especially in the short term, we do prediction using fine disaggregation of the basket. So we disaggregate across country, but also across components. So the type of exercise, complex exercise that we perform in the euro area, is able as a mechanism to deal with this. But of course, this is not for free. It's complicated because we have definitely what we have to do. What are the challenges? We have definitely to deepen, increase the knowledge and monitoring of non-fuels energy prices. So it's not fuels, but we have to study very well energy markets of gas and electricity in the euro area. The euro system projection are the exercise now is considering more and more the gas and electricity in their assumptions, and they're studying country specificities. So I'm telling you this, but the Eurosystem is already moving into this. And of course, we have to do another things. I have more than a decade of experience in central banks. Central banks are very conservative slow to change, but we have to innovate. We have to enhance modeling. We have to do new modeling. We have to account for time variation. We have to account for nonlinearities, especially in these extraordinary times. So we have to get a little bit on the edge. And we have to, of course, consider energy dynamics in modeling inflation of components that are very sensitive according to what we see now, for instance. And I mean, this has been explored in this nice workshop. We have to make use of new data sources, microdata, high frequency. For instance, a lot of energy prices in the euro area are high frequency with daily, weekly data. So we have to use new unconventional kind of data. And I conclude. Thank you for your attention. I mean, this is just to say that we have survived in the past. We can do it now. I mean, we are not as bad as we were with inflation in the 70s. There's a little bit of hope for the future.
With a bright spot. It's not as bad as the 70s. Thank you, Francesco. We have a couple of questions that came through. Let me start with Emiliano. If you can tell us a little bit on the foreign exchange channel, how your data is treating those. When we talk about input prices, are these only domestic or there's also imported inputs, and how does the foreign exchange enter the picture?
We try both. One in which we have just like domestic input price inflation, which is the one that I showed you today. If we include like a similar measure using customs data, we include it in the input price inflation. The results do not change much, and that one was the way that we dealt with the issue of the foreign exchange rate. However, something that show up when we include the external input prices is that the effect is lower. Why we think the effect is lower? It might be because of two reasons. One is custom data is noisy, but the other that could be a reason is because firms are forecasting domestic CPI inflation. Perhaps they weight more a local signal, like the domestic signal rather than the foreign signal. This is like the second. This explanation is that we think what is behind the results.
Thank you, Emiliano. And Mohammed, one question I had for you, and something that I also discussed with Shebnem for a while, given that, all the talk about reconfiguration of GVCs, deglobalization, what could your model say about the inflationary impact of potential deglobalization?
Thank you for the question. So our current model with the current setup, we take the given input-output relationships, given global value chains as it is, and we model what could be the inflationary effects, what the inflationary effects will be given that context. So we don't model reconfiguration yet, and we don't model the productivity, like implied productivity changes when we do these reconfigurations. So in order, if we add those into our model, I think first we will suffer from these productivity shocks, right? Because the newly, like if we reconfigure the global value chains at the beginning, we will have this productivity shock, and those productivity shocks will be inflationary because of the negative, like we assume it will be the negative nature. But then later on, it might stabilize and even become less inflationary. But I think that's the medium to long-term effect. We were focusing on this short-term effect in our current discussion.
Yeah, perhaps we'll be watching for your next paper to give us a more complete answer. And Francesco, so we had a couple of questions from Mario Porcedu. The question is, over which sample have you estimated the models? Have you considered time-varying VARs? And we have another question from Gianluigi Madruzato, who's asking, have your investigation on the role of diesel prices been done? Sorry, have any investigation on the role of diesel prices been done? about the inflation surprise in the euro area.
Okay, let me first answer to Mario, which is also my stakeholder at the ECB for forecasting inflation. So we have estimated also at the beginning of our analysis time varying models, but we were mostly the beginning of the shock. So let the shock propagate a little bit more. I do think that time varying estimate could report some more time variation when we will have a little bit more of observation, because empirical models need data, and if you have just 1/4 of the shock, it's difficult to find evidence enough to let the model make the coefficient change. But now that we have at least 1 year of shock, and then we will redo this. This is my hope that we will get a little bit more into also time varying models that, however, pose a challenge, because forecasting with time varying models is a complicated job, because then you have to discuss the time variation of your transmission. So forecasting with time varying models has advantages, of course, but as a challenge as well, especially in the euro system. So Mario, we will do this. Don't worry, I will keep you posted. About Gianluigi question, yes, of course, we are studying fuels in detail. We know that diesel had a different shock than the gasoline, because, of course, of all the big conflict in Russia and Ukraine that has a big impact on the diesel price and on the margins that goes from the refining process of the oil to diesel at pump. So we are studying this. There are market prices also that we monitor separately, gasoline from diesel, and we do this in the euro system on a frequency of the exercises. So we are aware of the peculiarity of the diesel situation, of course, and we use this information in our forecasting. Of course, then when we do fuels, we have to aggregate, but we study diesel and gas separately, and we observe and we monitor prices separately, and we decompose even prices separately.
Thank you, Francesco. I'm watching the time, maybe 1 more minute. Given for those of us especially who are in Europe, question is how much of the inflation spike is related to energy shock, which your analysis is answering some very good answers to. But my question is, we also heard some explanations that there might be a statistical bias, and maybe the inflation is not as high as it actually is, and we may get some payback in 2023, 24. What is your take on that?
Yes, I will give you a very simple example. There are 2 items. One is the telephone services. So this is my phone. In the statistical measure, inflation of services, they go, let's say, in statistical institutes, they go and check what is the cost of subscribe to let's say a mobile plan to do calls and go through internet. Every month they do this. What about the energy bill, the electricity bill? This is what they do, basically. They go every month and check what is the price of opening a new electricity line in my apartment. And this is not what households do, right? Because you have typically a contract that you've done 1 year ago, you did 1 year ago, or maybe 2 years ago, and maybe this contract is some fixed prices and so on. So, and in each country, there is a different structure of the market. So statistical institutes are aware that they can be overrepresenting energy inflation. They are aware of this. They are discussing this, and they are, the problem is that each country has a different situation. There are countries in which the price is variable, but I mean, it's time varying, and then the difference is not that big because my contract moves with the wholesale prices. There are countries with there is a lot of regulation and a lot of fixed prices, and probably Italy is one of them. So in these cases, the statistical institutes are maybe worried of overrepresentation. The problem is that the inflation figures are euro area, are harmonized. So it's not that Italy changed the way of measuring energy inflation. It has to be harmonized with the Eurostat, and the Eurostat has to agree to a revision of the inflation figure in the euro area. So it's something that involves a lot of actors in the theater, and it's gonna, the debate is gonna take a while. And the only thing that I want to say, you keep posting in 2023, and let's see if they agree to a new way of measuring it. But this is a big issue, of course. I hope that this answers your question.
Absolutely, and this is a great place to pass the word back to Ernest. Stay posted. We're going to get more answers.
Thank you very much, Denise. This brings us to the end of this workshop on challenges and recent advances in modeling and forecasting inflation. Without trying to do justice to the richness of the presentations, I think it is fair to summarize that first, in standard models, there is indeed a forecasting bias towards the inflation target. Notably, we may have missed important non-linearities in the past, threshold and regime switching effects. But second, huge efforts are ongoing in central banks and in academia. We have heard about some examples to enrich and to improve our inflation modeling and forecasting toolbox, including many different approaches and data sources. So central banks and other researchers take the quest for improving inflation forecasts very seriously indeed. Still, third, there is no silver bullet, as has become obvious also from the empirical results of the various approaches. Polycrisis, high inflation periods still have a challenge for inflation forecasting. But fourth, the various newly developed approaches indeed do improve our forecasting abilities. And finally, and obviously in fifth, we are still in the middle of an intensive learning by doing period, so mutual learning, like in today's workshops, are particularly useful. Thank you to all organizers, co-organizers, our speakers and moderators, and to all of you for your interesting questions and your active participation. Thank you very much. Bye-bye and take care.
Thanks so much.
Thank you.
Ciao. Bye.